Eventually quite some presentations in the afternoon. Please join them all. They will all be very interesting. So happy to guide you through the day today. We have only a lunch break today, so a full program. And if you have any questions in between, please reach out. So for today's workshop, you need the Wi-Fi and your laptop. So if you don't have your laptop open already, please open it up. We have a Wi-Fi password called Xebia guest with the password easy access. Usman will probably mention it again in a bit. So you probably already know Usman. Usman is the one and only machine learning engineer that can talk a lot about the graph frames library in Apache Spark. And he will guide you through the machine learning. First, always the first talk, right? Always going wrong. So he will guide us through the world of graph-based machine learning. So warm welcome for the one and only Usman Safar.
Thank you. So again, a quick mention of the Wi-Fi. Hopefully everyone is connected. There's going to be some setup later. Curious to see how 40 people doing pip install at once goes. I'm not sure our guest Wi-Fi is up to scratch, but we'll see. So yeah, indeed, today we're going to be talking about machine learning with graph networks. Kiki already introduced me very well, but just another quick brief intro. I work as a machine learning engineer with Xebia. Been here for a little over 2 years. Background in physics and computational neuroscience. Worked for several years as a data scientist, but also doing a lot of engineering. Before I had an identity crisis and moved over fully to an engineering role, but also missed data science, so I tried to do a hybrid of both. So the agenda, I'll introduce a little bit what we're aiming to do today in this workshop. We'll then go through some setup, make sure everyone is ready. The chance that something goes wrong is quite high, which is a large number of people, so hopefully we have time to sort out those issues. I'll then introduce the main library we're going to be using today, called graph frames. Go through some background about what it is, what it does, what it can do well, what it cannot do well, its limitations, and then go through some simple exercises just to kind of develop some familiarity with this, so that you have some better intuition about how it works, what it looks like, how it performs under the hood. And then we'll introduce the main kind of use case and main exercise for the day. So hopefully we can get through all this stuff pretty quickly, and we can get quite hands-on with the exercise. So there's quite a lot of exercises here. I'll be quite surprised if we finish them all. But if someone does finish everything, then I think we can maybe offer you a job. Is that right, Kiki? Yeah, very good. So the notebook we're going to be using today can be found at this link. So if everyone can navigate to here, should hopefully work for you. Already tested it with one or two of you, so. And if anyone has issues, just put your hand up and I'll come over and see if I can help out. Oh. Yeah, working for you. Okay, cool. Are you connected to the internet? Yeah. Where's your guest? Do you have like a VPN or something connected, potentially?
No, but I have a connect, maybe just.
Let's see. Okay. Can you? Yeah. Oh.
It doesn't go
Oh,
like this.
yeah, that's okay. It's just loading. It's just because I think the internet. Oh, yeah, that's fine. That's okay. It will eventually
Yeah,
load.
just
Yeah,
take
yeah. Strange. I'd recommend just maybe sitting there for now, just so you can at least follow one of the notebooks.
Getting on the way.
Okay.
Oh yeah, I also tried.
I guess hotspot, but this one is
But
also.
it might also be my laptop because I also
Okay.
had some issues yet.
The password was okay, or?
Yeah.
So, a couple issues. If it's not loading for you at all, then I think you can just sit with the person next to you, and then you can at least follow one which does work. And in terms of the slowness, I think that's just a case of our guest Wi-Fi not being up to scratch. So later on, we're going to be running a lot of stuff in this notebook. To begin with, I would recommend running the first cell in this notebook. It does a whole bunch of pip installs, and given how many of you there are, I think this will take a while to run. So hopefully by the time that we're through the introductory material, all the libraries will be installed and they're ready to go. Curious to see how this goes. You'll also notice if you try to save the notebook, you may get an error message relating to it not being yours, but you have an option to save one in your own drive as well, which I would recommend. Okay, so I hope everyone has at least now started to run the first cell, so everything is installed for later. We're now going to go through some terminology that is, just to make sure we're all on the same page for later. But before we start, a quick show of hands. Who here has done anything with graph networks or kind of, I see a couple of hands. Third. I see a Neo4j sticker, so your allegiances are already noted. Cool. Okay, so then it's probably beneficial to go through this. So what do I mean by a graph? I don't mean a bar chart or a line chart. I mean one of these things. So a graph, very simply, is made up of nodes, which represent objects or entities, and edges, where edges describe the relationship between a pair of nodes. And a pair of nodes may have a relationship, may have an edge between them, or they may not. So the most common kind of use case is always social media analysis, where nodes represent users and edges represent whether those two users are friends or not. It's always a useful example to have in mind when thinking about this stuff. So very simply, this is what a graph is. The edges between the graphs may be directed, like so. So you have node A connected to B, but not necessarily B connected to A. They also may be highly connected, where most nodes are connected to each other. On the other end, you may have a very sparse graph, where many things are not connected to each other. So in this case, in the social media example, most people are not friends with most users on that platform, in which case you have a very sparse graph. That has some interesting implications for later that we'll go through later. We can also have heterogeneous graphs, where different nodes are of different types. So they may represent different types of entities. And we can also have a weighted graph, where edges may exist, but there is some kind of normalized value which describes how strong that relationship is. Can also have disconnected graphs, where there are multiple subgraphs within this whole graph structure. And graph frames is a package we can use to process such data. So it is a package which uses Apache Spark under the hood, and it's built on top of data frames. So for those of you familiar with Spark, you may notice part of the core Spark package is something called GraphX, and this is built on top of RDDs, so processing graph data based on RDDs. Graph frames is effectively the same, but it's built on data frames instead of RDDs, so a higher level abstraction. The other difference is graph frames is not a core part of the Spark package. So if you've ever tried to install this stuff before, you'll most likely experience some kind of dependency hell. One of the reasons they did this was because the developers at GraphFrames, they wanted to utilize the latest versions of the core of the Spark optimization engine, which was always a few versions ahead of like the core part of Spark. So for that flexibility, they decided to develop this as a separate library. From here onwards, you can now open your notebook, and we can start. You can follow the presentation along with the material there, and that will also help you to be able to quickly run stuff whilst we go through different concepts. So now we've kind of spoken about what a graph is. It's made up of nodes and edges, and there's some mystical kind of stuff we can do with it. How do we actually create one of these things? Well, under the hood, it just operates on two data frames. One data frame which represents the edges of our graph, and the second which represents the nodes, the vertices. For the vertices, we need an ID column, which is just a list of integers, where the integer is a unique ID for the node. And you can also have additional columns which describe features for that node. And the edges contain a source and destination column, which describes the edges. So you may have a connection between node 0 and 1. And also, likewise, additional columns to describe various features of that data frame, of that graph. So what does this look like? Very simply, on the left-hand side here, we see our nodes data frame with our ID column. We have an additional column called author. So this relates to the use case we'll describe later. But for now, it's just some random letters. And here we have the edges, source and destination. So this means there is a connection between 1 and 2, 2 and 3, and so on. And to create this graph frame object, we quite simply just do this, where we pass in the nodes and the edges, and now we have this high-level object on which we can run various graph algorithms. Also worth noting, we can have directed graphs or undirected graphs. So on the left-hand side, we can see we define an edge between 1 and 2, but there isn't necessarily an edge between 2 and 1 here. Whereas in the undirected case, we have the reverse edges as well. Can anyone think why this might be relevant for graph algorithms or any type of traversal we might want to do?
You can use it to get some sort of sense of causality, right? A equals to B, then there would be an edge from A to B, but not from A.
Yeah, kind of. So let's say if we want to do a traversal from one node to another, if you only have the reverse direction edges, then you cannot traverse that. So if there's an edge between B and A, but not A to B, then you cannot go from A to B. And in some cases, you may want to represent your graph as an undirected, and in other cases as directed. So it's good to be aware of, especially because in the exercise later, this concept will need to be applied a little bit. So an example of what this looks like, just so the visual can be contextualized. So here you can see we only have edges in one direction. So we have from 1 to 2, going from here to here, and likewise with the rest. And in the undirected case, it's simply a case in both directions. Now that we have our graph frame object, a couple of attributes which are useful, and especially useful for the exercise later, are in degrees and out degrees. And this simply tells us for each node in our network how many edges are incident into it and how many edges are emerging from it. So can someone tell me, perhaps, for node 3, how many edges are incident into this? Yep. So 2 into node 3. So this is the in degrees. And just 1 for the out degrees. There's also quite a wide range of standard algorithms we have access to with graph frames. One of them is the breadth first search, which simply finds the shortest path from one vertex to another based on some conditions you provide. So this GIF, which surprisingly works in this PowerPoint presentation, describes how this works. The light gray represents a queue which has in there the nodes to be visited next. And when it turns black, that is a separate list which is maintaining what has been visited. And this is how it progressively searches through a graph and then finds the first node which meets your condition. So if you think about a very large graph, you may have some kind of particular type of path you're looking for. Performing such a thing is quite straightforward in graph frames. Quite conveniently through a function called BFS, where the first argument is a condition on your source node, and the last argument is, the second argument is a condition on your destination node. So in this case, it's going to find all instances where the node, the source node has a name of Esther, and the destination node has an age of less than 32. So in your notebooks, you will also see a diagram of this kind of friends graph in there visually, so you can see what it looks like. And that's also an example you can run, assuming everything else is installed. So if you can run this example in the notebook, then I think it will be a good start, because then we can validate everything works in terms of your installations. And you can also, once you run this BFS example, you can also see what the results look like. So there's 2 examples in there. One is quite straightforward, and the other one returns something a bit more complicated. And so then hopefully you can at least see how it starts to build up these results. And if you have any issues, just please raise your hand. Yeah. I think just the
anybody to facilitate with you? Or? No?
No? Oh, there we go. Yes. Open? Oh, okay, cool.
Okay, okay.
Yeah.
So it's-
Yeah.
okay.
So another cell you can run is the one above the BFS one, which is just printing out for, it prints out the result of the in degrees and out degrees. So it's useful to know what the output of this result looks like, just because you will need it later on for your task. So I think I saw most people who've run something now. So I want to jump back out of the notebooks and back into this for a bit, also relates to a question I received. You'll notice when you play around with this max path length, you'll get varying results. And you'll also see the really long result you got for the second one. And now this kind of comes to a bit of a, I would say, maybe a limitation or misunderstanding about how GraphFrames works under the hood, and why sometimes it's maybe not the best solution. So what's happening when we're trying to find all these different paths between two different nodes, and we're defining this max path length, what is actually happening under the hood? So a graph can also be defined by using an adjacency matrix. So here we have along the rows all of our nodes and also in our columns. And whenever two nodes are connected to each other, we have a 1. So you can see here, 0 is connected to 3. So at 0 and 3, we have 1. And this is undirected, so we will also have the reverse case, 3 and 0. We have a 1. So just a 1 wherever there is a connection. Now the adjacency matrix has some interesting properties. One thing we can do is square this matrix, and we have this result. And can anyone tell me what the significance of the squared adjacency matrix is? So this is quite a neat result. But what this now tells us is the number of two path lengths that we have between our nodes. So if I say 1 and 3, we see this value of 2, which means between 1 and 3, there are two ways how we can get there. We can go 1, 4, 3 or 1, 2, 3. And so for every, and you can imagine for 3 length paths and 4 length paths, we need to continue squaring this thing. Now, why is this important? Because the adjacency matrix is more or less the edges of our graph. So this you can consider a fairly efficient representation of this matrix. It contains all the non-zero values in there. And so if we say we have this edge representation, and this represents our adjacency matrix, how do we square this? How do we square this data frame? That's done by joining the data frame on itself, where on the left side you keep the source, you do it on the source, and on the right side on the destination. And then when you multiply the two values together, you effectively have the same thing as doing this like row times column multiplication repeated times. So for every time you want to do one path further, it's a join. And one thing we all know about Spark, and joins are very expensive, especially with very, very large data frames. So when you want to do this kind of, just endless star search to any kind of node, it's not going to be very efficient. Because under the hood, it's just two data frames. Unlike Neo4j, where a lot of this data is, or any other graph database system, a lot of this information is already stored. And so when you query those graph database systems, you can do those kind of results where you have this infinite length path, because the data is inherent in how it's stored. Whereas here, we need to do this, all these calculations are being done at query time, not the right time. So depending on your use case, how many paths you may want to investigate, it's not always wise to increase that parameter too much. So that's a little bit about why it may be a shortcoming for some use cases. So BFS is one such example of algorithms. Another one is the triangle count, and this counts the number of triangles in your graph. And the kind of the intuition here is that it can measure the cohesiveness of a certain part of a graph, or a graph in total, how connected these entities are. Another powerful feature is called motive finding, and the best way I can describe this is it's like regex but for graphs. So you can define in this kind of DSL type way some condition, and it will return for you all instances in the graph which match this condition. So here, our condition is that some node, going to call it A, is connected to another node, B, by an edge, which we call E. And we also want for that node B to be connected to A via another edge, i.e. the reverse edge. So in that case, it will return you all instances where two nodes are connected to each other. Quite straightforward. So it's like a pattern matching way of extracting subgraphs from your graph frame object. But there's also some restrictions about what you query here. So we cannot just say, give me an instance where A is not connected to B. Because in a graph, there are very, very many negative cases. And in our data frames, we only store the positive instances where two edges are connected to each other. But in some cases, you may be able to filter on a negative edge, depending on whether it's whether you filter on one direction existing and the other one not existing. So the next thing I would recommend is if you follow this link here, this will take you to the relevant documentation for graph frames, and there's a real kind of long block of descriptions about this motive finding feature, what it can do, what it cannot do, which is useful to understand. So this is for the second exercise later, but I'm not sure we'll get there, so it may not be too relevant. But just this link is also in your notebooks, so just something to note. So conscious of the time, I would now want to finally get on to our main exercise. Hopefully we're all experts on graphs now. So this data set we have, it relates to a list of research papers. Each paper is associated with a number of authors, the year in which it was published, and its title. We've processed this data so that the nodes represent the authors, and the edges represent whether or not they have collaborated with each other. Data is also split, so a bunch of papers before 2006, a bunch after. And the aim of this task is to predict in our test data whether or not a pair of authors are going to collaborate. So what it looks like, in our historical data, we have all these known collaborations. So one collaborates with 3, one with 4, and so on. And for an unspecified number of nodes in the future, we want to also predict whether they're going to collaborate or not. So how do we do this? How do we kind of go from this scenario to something that can kind of go into a simple classifier? Our input data looks like this. Each data point is a pair of nodes. So here we have 1 and 3. We have some features to describe these two nodes. And in this exercise, all the features we're going to create are order invariant. So it doesn't matter if it's 1 and 3 or 3 and 1, it should be the same. And we have some known labels. So this is a more kind of typical setup, right? Just a handful of features, some labels, can very easily put this into a classifier. In the data, there's also some functionality to sample some negative edges for this, so that we have a balance of positive and negative cases. So our classifier is more useful. Worth to note, if authors collaborated several times, we just remove all the future ones and take the first date at which they collaborated. And then that pair will not then be seen again in the test data as well. This is what the edges look like. So it's just, again, quite simply source, destination, and a label of 1 or a 0, depending on when they collaborated, and some our vertices. I don't think we need any of the features from here, but they are included. The ID is the most important one. So this is what goes into our graph frame object. And the first exercise is to create a feature which we've called preferential attachment. So this produces a score for each pair of authors by multiplying the number of co-authors each has. So the intuition here is that 2 authors are more likely to collaborate with someone who has already co-authored a lot of papers. So here we see author 0. They've collaborated with 3 authors. And author 2 has collaborated with 2. So for these two pairs of nodes, this feature value would be 6, 3 times 2. In the notebook, we will see a, if you scroll down, there is an example graph here where we have our positive edges in a solid black line and a handful of negative edges, which I've just done dashed for now. There are more possible negative edges, but I'm only including the dashed ones for now. And this sample graph is created in the cell below and can be used to validate the implementation of your functions. So if I scroll even further down, we'll see that there is our task is to, if I scroll further up, our task is to implement this function. The input of it is a graph, and the output of it is a data frame. I'll show you what that data frame looks like in a second. Once you've implemented the function, there is a cell below in which we can test this. So just a very quickly hacked unit test to validate this. And also by looking at this graph here, I can also validate my results quite easily. So I can say, okay, so what is the value between 2 and 4? Well, 2 has co-authored papers with 2 people. 4 has also co-authored papers with 2 people. So then I would expect the value for that one to be 4. So using this graph should be easy to quickly validate your results. And once you're ready for that, you can run the cell below, which then trains the model on the actual data, and then print your results. So what does this, so if I scroll to this trained model, you'll see we have a training graph and a test graph. And the input for this function, once it's implemented, is simply the graph. And the output is a data frame with that feature value. What does that look like? It looks like this. You'll notice the first part of it is just our edges, so source, destination, and our label. And then also the feature value here. And then what we eventually pass into the classifier is this as a feature, and then this as a label. Something which is worth noting, our graph frame object, G, has 2 attributes, one called edges and another one called vertices. And this just gives us access to the underlying data frames on which it relies on. And so to give a hint here, I think it was already mentioned somewhere in the notebook, but in case you didn't see it, for the preferential attachment, the functionality within graph frames that we need to use is the in degrees and out degrees. So that can be used to calculate this value, because that gives us access to how many nodes each node is connected to, which is effectively how many co-authors that node. So that should give you a hint about how to structure this. So to give a bit of a further clue, all the functions you should need are these 5 here. This first one transforms a graph from directed to undirected, so adds in the reverse edges. This attribute just gives you access to the edges. This attribute to the vertices. And these two, as we mentioned before, the number of edges going into a node and then the number of edges going out to a node. So just using those 5, you should be able to implement this function. Oh yeah, so it's supposed to return a data frame which looks like this. So effectively your edges with this extra feature joined on. So it's yeah, returning a data frame. Yeah.
Trying to get it into this undirected graph,
Mhm.
and there should be nodes for edges, or vertices or edges, but somehow I cannot get the edges.
Input G. So I think the it's edges, and like you have to type in the full. I think here you're trying to access one called V.
Yeah, because I thought maybe that's.
It's called vertices and edges. Yeah. So this one I think is vertices, not nodes.
Ah, thanks. Yeah, you have to do it in the function. I just did this.
Hmm. It's hidden all along. I said it's hidden somewhere all along. I'll reveal later. Yep.
This is the testing, right?
Mhm. Yep.
So there's from node 0, there's
Mhm.
1, we have degree 1.
Mhm.
Because this is negative.
Yeah.
But somehow in my table with the edges there's an edge.
So I have 1 minute left, so I'll just wrap up. I would not feel too dismayed if you did not get to a working solution. This is part of a wider multi-day training, so well, not all of it, but so it's a lot of material to take in. But hopefully you at least were able to get a little bit hands-on with graph frames. If you scroll to the very top, towards here somewhere, you'll see a Git repo. The answers are inside there. Maybe some of you already figured that out and cheated. So if you're curious, after the next talk to see what the solution looks like, there's a file in this repository called answers, or answers.py somewhere. And then the implementation of those two functions is there. You have access to this notebook, of course. It's and the repo will stay open, so you can continue to work on it later on if you want to at your own pace. I'll also be around afterwards if you have any further questions on this. I hope you enjoy the next talk, ML systems design. Thank you. I see Roy is not here now, so if anyone has any questions, feel free to ask them away, whilst I can still stay here.
I was wondering, is there any way to visualize at least parts of a graph frame, or installing PyGraphviz, for example?
Yeah, not within graph frames. I always just use I think Network X or something to do this.
Okay.
Yeah.
Thanks.
You're done, right?
Yeah. Yeah.
Anne? So guys, thank you very much for attending this great workshop. So for the upcoming half an hour, you have a coffee break before we will kick off with the next workshop on system machine learning. System design. So hope to see you back in 30 minutes.
That's
Hello, hello.
So welcome back, everyone. For those that just joined, welcome at GoDataFest Day 2. So today's our sponsor, Google Cloud, and they will make sure that we have a great day today. So thank you, Google Cloud. Again, a warm applause again. So we just finished a great workshop by Usman, and it ended so quickly that I forgot to present him with a beautiful bottle of wine to thank him. So thank you, Usman. And it also brings us to our second workshop. So next to me is Roy. Roy is also working at Xebia Data, machine learning engineer, but he's way more than that. He has a background in chemical engineering, became a bit more like a software engineer, and ended up as a machine learning engineer. But that's not the only thing he's actually building. If you have any questions about how to build a house, not how to finish a house though, please don't ask.
Almost there.
Almost there. But today he will actually help you in understanding how to, or the system design for machine learning. So Roy, the floor is yours.
Thank you. Yes, today we'll be talking about designing a machine learning system. So let me first introduce myself and explain why I think I'm the one to be telling you about this, or why I think this is important. So I started my career, as Kiki said, more as a software engineer, and there we used to design quite a lot. I worked for quite some time at ING, which is a complex, which is a bank, which automatically makes the IT pretty complex. And there, if you wanted to get anything done, it was pretty useful to design things up front, because otherwise you would get into discussions with risk, with security, with whoever else had something to say about your system. And actually, when I joined Xebia Data, I took this on, because what I noticed at clients is that very often you join the project and a lot of decisions were made, but when you joined the project you had literally no clue why these decisions were made and from what principles they were made. So I'm always at a client trying to introduce these techniques and technologies to help them design better systems, and yeah, I hope that I can enlighten you a bit as well. You have a lot of stuff in front of you. We will use that later for this workshop. You will be collaborating in groups with the ones that are at the same table. So those that are on the table by themselves, please join another table. We will do that later this workshop. So what I hope that you'll be able to do by the end of this workshop are three things. The first thing is understanding the importance of machine learning system design, why I think this is important to know. The second thing is, by the end, I hope all of you have designed a machine learning system from scratch. It's an ambitious goal, but let's see if we'll get there. And I hope that also you'll be able to better understand how to make and identify trade-offs in a machine learning system. That is also why you're collaborating with each other, because if you work on this together with different roles, with different people, with different ideas, you strengthen each other and you can challenge each other's ideas. Otherwise, you very quickly get to a very biased solution. So, without further ado, what do I actually mean with system design, and why is it important? Well, it's important because you want to make the right thing. And with making the right thing, I mean you want to make a thing that actually meets your business requirements, a thing that your business stakeholders tell you to build. And then the second thing is you also want to make that thing right. It would suck if you start building a thing and after months of development work, you notice that this thing either doesn't scale or doesn't work the way that you thought it would. So you'd better think of some things up front. And in the end, I'm also convinced that you can actually move faster if you design up front. I I don't know who agrees here, but we'll see. And then finally, I told this before, it's about communication and documentation, because if you build this design and you have 2 pieces of paper in front of you, that serves already as documentation. And communication is maybe the most underestimated skill in engineering whatsoever. You need to have a common understanding of the thing that you're building. So I hope with these tools we can actually do that. So now that you know why we should do system design, what is system design actually? So I think, excuse me, system design is the iterative process of defining a software architecture. So we're going to define a software architecture. And what contains a software architecture? Well, it defines the building blocks that you need, the interactions between these building blocks, and how data flows through these building blocks. Then finally, and this is the most important thing, like I said, you do this through analyzing business requirements, and also very important, which is often overlooked, and it's a bit hard to do in this workshop because we're going to use a fictive use case, the context of the organization. Because often if you work within an organization, a lot of choices have been made for you, or by other teams, by other departments. You need to take that into account when you're designing a system. So what then is a software architecture, and what things are ruled by it? So one of the software architecture is that everything is a trade-off, and that's what I also hope that you'll be doing during this workshop. Is if someone has an idea, challenge that person on the idea. Why do you think this is a good idea? And preferably also document these ideas and these trade-offs. You don't need to do it now, but that's what you would typically do during a design session. And finally, why is more important than how? You can describe how a system works, but it's more important to explain why you made the decisions to come to this system. So we've discussed system design by now. What makes machine learning system design different than normal system design? Well, machine learning systems consist of roughly 3 parts: data, model, and code. And because data is the huge component, the data that flows through your system, it can change. So your system needs to adapt to this changing environment. The data can change. Models, they can be quite huge, especially with the move to LLMs, etc. How are you going to deal with that in your production environment? How are you going to make sure that that system actually scales? And finally, monitoring and debugging models is non-trivial. Yeah, that's all I have to say about this, actually. Then I want to make a small sidestep. So how does this thing relate to MLOps, which is a very popular term nowadays? So machine learning system design relates to MLOps in a way that it takes a systems approach to MLOps. You look at your problem from a holistic perspective, and you try to solve the problem. This is actually a quote by Xebia. I drew a lot of inspiration from her book, Machine Learning System Design. I'll get back to that later. So in a schematic representation, what is a machine learning system design? What does the system look like? So in the end, we have the end user, and it interacts in some way with your system. And we have business requirements that drive what the system looks like. And then the system contains your deployment, how you're monitoring stuff, what data are you using, what infrastructure, what machine learning algorithm. All these things are part of your system. And I hope that you'll be defining that today. Then what would it look like? Well, very schematically, it looks something like this. You have an application that sends some data to Kafka, for example. This is not for this use case. Don't draw it. It's not like a sneak preview to the solution. But this is something that what the system would look like in the end. Just to give you an impression of what we're going to do. So as I said, we're going to use a fictive use case, and this fictive use case we call Fancy Fashion. So what is our Fancy Fashion company then? Well, it's a sustainable fashion startup that helps people sell and share clothes. Think Vinted. And what people can do is people can upload pictures of their items, and they can sell these items on their platform. A key part of the app will be a model that automatically labels and uploads, that automatically analyzes the uploaded images and assigns labels to them. Then finally, we have a model that is in the POC phase, so we know that this thing can add value, and it can classify images into preset categories like bags, sneakers, dresses. You don't need to remember all of this. I'll put it on the slide later when you start working. So to help you and guide you a bit through this process, I've defined this workflow. That's the thing that's on these canvases that you have on the table. So let me, please pull it up if you want to have a look at it. Feel free to do so. So I've Okay, you don't need to start working yet. Just use this as reference. I'll now walk you through this entire process to explain you a bit what the different segments are. So I've defined the entire process into 6 segments. I'd advise you to go through them chronologically. That's why the numbers are there. That helps you design and build this system. So I will give you these beforehand because I think that scopes the thing that you guys will be working on. So I've defined the requirements already. Again, this will be put on the board in a second. You don't have to write these on your piece of paper already. So first, what is the business objective that we are trying to solve from this? So the business objective is twofold. It is to reduce time to post a new fashion item. If we can speed up this time, probably our users will use the platform because it's easy to use. Secondly, if we are able to classify items better in the right categories, items are easier to search, so that will drive sales. Second question, what functionality do we need to support? Well, for now, just assume that we want some way for users to provide feedback on the classifications that we make. I'll give you an idea of the scale of the system. Typically, you would, if you go through this exercise, you would include your business people, and they can hopefully give these answers. If they cannot, probably you're not there yet to design the system. So what is the scale of the system? Let's assume we have 1 million users. 80% of them are buyers, 20% are sellers, and sellers on average sell 10 items a month. You can make some assumptions on the scale there. And we want predictions within 500 milliseconds after uploading an image. If you have any questions about these business requirements, when we start, please feel free to ask me any questions. There's always people with very interesting questions about these, so I'm happy to hear them. Now, the second thing is frame the problem as a machine learning task. So do we actually need machine learning to solve this solution? Well, oops. Am I still audible? Yeah, so, yeah. In this problem, I think it's pretty evident that we need machine learning. But very often, a rule-based system, if you have tabular data, can do the trick. This system that I've created, it's not specific to this use case. I think you can use this framework for any use case that you would make a machine learning system design for. So secondly, define the machine learning objective. So in the previous slide, we said, okay, we want to reduce the time it takes for users to upload an item. You can do that in multiple ways. So we say, okay, we want to classify images to do that. But that's the second thing that you want to do. So third, what category of machine learning model are you going to use? I think that speaks for itself. And then fourth, if you're going to drop the design, it's good to think about the model input and output. Because then you can define the boundaries of the system of your model. Then third, what are the data sources that you're going to use? Here, you're probably going to make some assumptions as to where your training data is going to be stored or where it's going to come from, but typically that's good to identify. Secondly, in this, this relates a little bit to the first question, is what type of data storage do you need? Like, is the data already in a type of storage that you need, or do you maybe need additional storage systems because your system that you've designed needs it? Think of things like Redis or something for quick responding to requests. And then third, what is the quality of the data? Again, here in this case, you're probably going to have to make a lot of assumptions on that, but that's also important to think about. Then point 4 is the development and evaluation of the model. Typically, data scientists have quite some experience with this, but let's go through this anyways. So do we have a baseline model available? Well, in this case, as I said, we have a POC already, so let's assume that that's our baseline model. What algorithm are we going to use for our model? Maybe not very relevant here, because we cannot even test out algorithms. And how interpretable do we need the model to be? Does that apply to this use case? Or is it maybe not relevant to the use case here? Where will we actually train the model? What infrastructure do we need, for example? What system do we need there? And then we've defined in step 2 the ML objective that we want to do, but what training metric best reflects the objective that we actually have? And finally, how do you treat fairness and bias in your model training? In this example, does it, for example, matter that you're better at classifying male trousers than female trousers? I don't know. Think about it. And then once we've trained the model, we actually want to serve it in some way to our customers so that they can actually use it. So where will we execute these model predictions, and what type of services are we going to do that? Do we need some way to test our models in production? Think of A/B tests or canary releases or whatever. What suits your problem best? Then, do we need specific technologies to make sure that the model that we're using scales in the way that we want it to scale? And then what I always like to describe is also, what does your CI/CD workflow look like? How do you ensure that you can automatically and quickly release or update the versions of the model that you have running in production? And then finally, we're almost there, you can almost get to work, is observability. So how do we know that the model is actually running in the way that we want it to run? So what technical metrics do we want to measure? We have this metric of we need to respond within 500 milliseconds. How do we measure that we're actually doing that? And then finally, the model performance metrics. So how do we ensure that the model still adds the business value that we think it adds? It can still respond within 500 milliseconds, but if it doesn't classify correctly, it's still not the right model. So again, we've went through the entire process. Focus on creating something like this. I think that drawing is most important, and the question should guide you in the decisions that you need to make. So I would say start with filling out this canvas, and when you're at point 3, or maybe if you're at point 4, start making some sketches. So start creating some drawings and iterate on the design that you have. Again, these are the requirements. This is the description of the use case. Yeah, start discussing with your team and see if you can come up with something. Maybe the 2 guys that are at the back can join here so that we have bigger groups. Because I prefer people to work with teams of 3 or 4. You're also 2. I think there's a group of 2 there. Oh, and I see those are moving. Yeah. And please let me know if anything is unclear. I'd be happy to help you. Okay. I lost a bit track of time. Okay, everyone. Thanks for the enthusiasm. So, also the group in front of here. Everybody, thanks for all this enthusiasm. What I would like to do is pair up groups and give feedback to each other. So I would say find the closest groups. So let's pair up these two in the back, these two, and then I'll give feedback on you because you're we're with uneven numbers, unfortunately. And take 5 minutes to have a look at the other people's canvas and to have a look at the diagram that people made and give feedback. Like try to understand what the diagram does and see if we can learn from each other. Okay, so you're paired up with that group, I think. You're paired with that group. These two are paired. Okay, that was 5 minutes. Please switch groups so that the other group also gets their feedback. For those that have not switched groups yet, please switch. Okay. Thanks. Please get back to your seats. Could everybody please move back to their seats? I like the enthusiasm in the back. There's one group still heavily discussing. Would you mind getting back to your seats? Okay, okay. Okay. Yeah. So let me wrap up this session. But before doing that, I also drew my own architecture. You can't see all the assumptions that I made here, but this is more or less the thing that I created, and it's definitely not complete, but it has some nice components. So yeah, I'm sorry, I'm going to point things here because I don't have a laser pointer or whatever. Can you see my mouse? You can. Nice. Okay. So here, at the top left, we have the customer. You can interact with our system through either browser or mobile app. Doesn't really matter for our design. And that will go to some backend system. By the way, I created some images in gray. Those are like external systems, like not maintained by our team, so to say. So we integrate with this backend system. That's some other team that's doing this. That team, like, it collects all the uploaded images and stores them in some data warehouse. That's what we can use for training. So we have a model training pipeline. And what I always like is to have some data exploration service. So I have a Jupyter notebook from which I can interactively read data. I can develop a model, but then once I have something that should go to production, I always want something that's repeatable. So we have a model training pipeline. Once the model training pipeline is done, it stores stuff in a model registry. That's where we keep our models. And now we have a CI/CD pipeline at the bottom that pulls the latest or best version of this model from your model registry. I did not include any specific tools that you would use here. We could discuss this later. And that deploys our model API. This is a REST service. And that backend system that I mentioned earlier sends the image over HTTP and just sends back the labels. And so in my drawing, this backend system is also responsible for gathering my feedback, that it puts the right images and the right labels in this data warehouse. You could also say that this model API should be responsible for that. I did not make that decision. Then I have some monitoring system. I said here Prometheus, that creates my HTTP metrics. So I'm only technically correct because I don't have any monitoring for my business metrics. That could be an improvement here, but this is more or less what an architecture could look like. But it's not very detailed. Anyone has any question or remarks or whatever?
Max, one question, Roy. Only one question. The rest is for during lunch.
Okay. Let me quickly wrap up then. I'll skip this slide. Then I wanna mention this because these are the sources that I use. These are 3 great books. I won't go into detail. You can ask me about it. I wrote a blog about how to do machine learning system design for a different use case. So you can read that here. There's a link here and one back. And I created a training in where we go much more in detail into how to do machine learning system design. Because as you saw, you've only barely scratched the surface here. Yeah, we will go much more in detail into what tooling you could choose, what are the trade-offs between different toolings that you could use. And you also use fictive use case, but you also work on your own use case that's really related to your company. Yeah, that was all. Thanks for being here. I like this very much. I hope you enjoyed it as well.
Thank you, Roy. Not very surprisingly. Sorry, we have lunch right now. Is it okay to ask a question during lunch? Amazing. Sorry for this. So, not very surprisingly, we also have a bottle of wine to thank you. So hopefully you can drink it in your new house at some point. So that also brings the morning workshops to an end. So we'll have lunch. Lunch will be served at the bar. You can just have it anywhere downstairs. And at 1 o'clock, so in about 30 minutes, we will continue with our keynote speaker, Peter Bavink from Google Cloud. We'll talk about how to leverage Google Cloud to smoothly work together between data engineers, data analysts, data scientists. We will learn how to actually buy a proper house without having to build it yourself with Funda.gpt. And last but not least, we'll also have Molly here talking about how to bring LLMs to production. So it will be an interesting afternoon. So hope to see you back at 1. And the door is closed, so we can continue the day. So today I have with me Peter, and Peter works for Google Cloud, and he will provide us with all the insights how you can leverage Google Cloud to, what is it, break the barriers between data practitioners. So give him a warm welcome. Peter!
Hey everyone, this is working, great. Thank you so much for Xebia for inviting me, of course. Happy to be here. Let me first introduce myself. I'm one of the customer engineers working for Google Cloud with a focus on data analytics. I'm almost 10 years at Google Cloud. And when I say that, most people go like, what? Is Google Cloud already 10 years old? Yes, it's 10 years old. But let's say for the last 6-7 years, a really strong focus on Google Cloud Platform, which of course also includes our data cloud. So breaking barriers between data practitioners. Breaking barriers has been part of our philosophy for a very long time within Google Cloud, generally speaking. So as an example, with serverless technology, if you look at our data stack, things like PubSub, BigQuery, Dataflow, these are all fully serverless functions, services that are available that help data practitioners reduce the dependency on infrastructure people, if you will, and processes. So that's just one example. Another example where what we've been doing for years now is enabling business users to do complex analysis based on a centrally defined semantic layer powered by our Looker infrastructure. So you define, your semantic layer once, and then through Looker functionality, you are able to dynamically generate complex SQL statements to slice and dice your data. Again, reducing the barrier for business people to get back to data analysts all the time. But today I'm going to talk about some innovations that we've announced last month. And I'm going to end with an actual demo. So there's something to look forward after these slides. So I'm not going to spend too much time on this. We all know that there's a ton of data and it's growing at an increasing rate. We also know with the AI and more recently large language models, the number of use cases or the application of data for business impact has significantly increased as well. So there's more data, there's more demand from the business, there's more use cases that can now be implemented using data, which is great, but at the same time, we still see that there's a large amount of use cases that never make it to production, right? We all know the situations where the data scientist builds a model and 9 months after, having a working model, it's still not in production. So to make things simpler and increase that number of getting things done, we have a strong foundation based on BigQuery. So BigQuery plays a central role in what we call our data cloud. So our data cloud is basically a portfolio of integrated services that are aimed to support every user in the data lifecycle and support every data workload that you can think of. And BigQuery plays a central role in that. It's not doing everything, but it plays a very central role. BigQuery is another example of a completely serverless service. So it's always on. There's no upstart, it auto scales, right? So there's no cluster that you have to manage or have to duplicate if you run out of the number of cores that you have available. It auto scales. You pay for what you use. It separates storage and compute. So if you query, but you don't own the project where the data is stored, you don't pay for the storage, you only pay for the compute. That enables great sharing capabilities. So if you want to monetize your data with other organizations, you pay for the storage, but let somebody else pay for the querying, and basically you can sell your data. But I'm not going to pitch too hard on BigQuery. But it's very important. And BigQuery traditionally was only petabyte scale data warehouse. But in the recent years, we've enabled a technology which we call Big Lake, which allows you to work natively on GCS, Google Cloud Storage, where you store files in open formats like Avro, Parquet, Iceberg, Hoodie, and many more. So without moving or ingesting the data into your data warehouse, you can basically query and work with your data directly on the files in your object storage. Big Lake also enables you to have fine-grained access controls. So it has a unified model where it doesn't matter whether the data is stored in BigQuery or in one of those open file formats. You can still apply your column level security or your row level security in the same way. And that's, of course, a big benefit. We've even expanded BigQuery across different clouds. So if your data is stored on S3, you can use BigQuery with the extension which we call BigQuery Omni. You can work with the data on S3 as well. All right, so of course, the big focus of everyone today is, okay, how can we leverage data and apply it for artificial intelligence? And so there are many roles that play at this scale in this life cycle. And what I'm gonna demonstrate to you is that with Google's Data Cloud, what we are aiming for is breaking the barriers of the individual of these roles. So the traditional data engineering role, a traditional data analyst and a data scientist or a business user. And we basically expand and empower these users to do more in that life cycle. And by doing that, we basically enable them to do more with less, right? They have less dependency to other people and other teams to get the job done. And this contributes, of course, to a shorter time to market or an increase in productivity. So BigQuery is already a great start. It has been a great start. You can query your data directly from your transactional systems without, having complex ETL jobs bringing the data in the data warehouse. You can just use federated queries. It supports the lake. It has, BI accelerators for fast dashboards on top of it. And of course, it's tightly integrated with Vertex AI, our machine learning platform. But there are still some challenges. So still, these data practitioners have to use different tools to work with the data, right? They still have to switch between different applications to get the job done. SQL is great for a wide range of jobs, but Python is another great language for another set of workloads. So do you have to choose or can you combine that sort of stuff? And of course, GenAI requires complex infrastructure, and how are you going to manage that? So we announced BigQuery Studio, which brings different tools and technologies and services under one roof, supporting data practitioners for a wide range of workloads. And I'm going to talk about these individual aspects here. So unified analytics. So we provide a single user interface where you can basically work with these different technologies directly from within the BigQuery UI. So what does that look like? You're welcomed with a welcoming screen where you can see your recently accessed stuff. On the left-hand side, you see the maybe familiar to some of you, the familiar tree where you can see all your aspects of your project that you work with. And of course, for SQL, we've which is the bread and butter of a data warehouse, we have enhanced the capabilities in this as well. So now, for instance, you can visualize your search results or your query results immediately directly within the BigQuery UI instead of having to export it to some visualization tool. You can have different sorting and filtering on it directly on the results as well. Another key thing that we've done is integration with Dataplex. So Dataplex is our governance solution, which automatically harvests metadata from all the data sources. You can ingest your own custom metadata if you want to as well through the API. And Dataplex provides data lineage, data profiling, and data quality. And we service the results of those scans and those tasks directly in the BigQuery UI. This, for instance, allows you to get a sense of the data immediately in the BigQuery UI when you look at a table, instead of having to go to another application, do some profiling information there, and then take your conclusions. So this simplifies the workflow as well. Now, looking at Python, Python support through notebooks, of course, is a tool of the trade for many data practitioners. And we've had notebook support on Google Cloud for years now, but we've just released Colab Enterprise based on the very popular Colab notebook experience that some of you might have experienced as well. And of course, the Enterprise tag means that it's fully supported and you have basically the full integration within Google Cloud as well. And the nice thing here is that Colab Enterprise is directly integrated within the BigQuery UI as well. So you can immediately switch between your SQL work back to your Python exploration and so forth. I'm going to show that in a minute. We also launched a new interface on top of Pandas and on ML, which allows the popular Pandas data frame interface be available on top of BigQuery. What I mean by that is that it allows you to work directly on the data frames which are represented within BigQuery materialized data by itself, instead of having a memory abstract of your data. So data frames normally work, on a subset of data in memory, and this allows you to work on data frames that are, gigabytes or terabytes or petabytes in scale, because they're materialized within BigQuery in tables. And we're going to show that as well in a minute as well. The same for machine learning. So we have the familiar scikit-learn interface, which then works directly on BigQuery ML. For those that do not know, BigQuery ML is native machine learning support directly in BigQuery through an SQL. Standard is in SQL, so you can write your model, you can train your model, and you can inference your model directly through SQL statements in BigQuery. But now with BigFrames ML, you can also do this directly through scikit-learn interface. So Spark, another great tool of the trade, right? Google Data Cloud always says, we're the most open cloud there is. So we have this wide range of open formats, but we also want to support, very popular open source framework. And Spark is, of course, one of those. So now it is possible to run Spark stored procedures directly from your SQL statements in BigQuery as well. So instead of, having different platforms for different workloads, you can actually do hybrid workloads using SQL and PySpark directly in a single interface. Under the hood, this is using another serverless function, which is serverless dataproc. So dataproc provides a serverless Hadoop Spark environment, which is ephemeral, right? So it spins up a cluster super fast, it does the workload, and then it shuts it down. So you don't pay for long-running clusters, that sort of stuff. It's fully automatic, it's fully serverless, and hidden from the user. And of course, large language model support, the talk of the day, right? Duet AI is our naming for the collaborator in all the Google Cloud services, and there's a Duet AI embedded in BigQuery as well. And I'm going to talk a little bit in more detail about that in a minute. So having the data in BigQuery, getting it in there, and then transforming it, typically we've seen a transition between ETL towards ELT, right? Extract the data, load the data in BigQuery as quickly as possible in a raw format, and then start transforming in the warehouse instead of doing the transformation outside of the warehouse. Now, of course, this doesn't work for all use cases, but for a large amount of workloads, this is a more efficient and an easier way of doing things. And to make this even more easily, years ago, we acquired a company called Dataform. I'm sure you all are familiar with DBT. Dataform is a very similar tool that is now directly available in BigQuery. So you can write your transformations, schedule your transformations, have your complete GitOps approach on these pipelines directly built in BigQuery. Again, so without having to go to another application, another tooling, it's all under one roof, and you have a powerful data transformation pipeline engine running directly within BigQuery. So I talked about notebooks, I talked about pipelines. This all comes with Git supports built in. So you have full version control, source control. You can support, the pull request and the approval cycles that come along with that, basically straight from within BigQuery. Then I already mentioned Dataplex. Dataplex provides data profiling, data quality, and data lineage. So everything you do in BigQuery gets exported. The metadata basically gets exported to Dataplex for storage and for visualization. So you can always see what happened with my data, what were the transformation, at what time did they occur, and what did they result, what are the dependency between the different data assets. So this is in Dataplex, where the governance solution where you can find, search your data, and work with your data and see that information. But again, you can see this now in BigQuery directly as well. So let's talk a little bit more about Duet AI. So Duet AI is directly available in BigQuery, and it services itself in different ways. So one of the ways it does this is by selecting SQL code and simply clicking a pencil, and it will explain what the SQL statement is actually doing. So this is, of course, great if you're working in teams and you get an SQL statement from your teammate, and of course, you can read it and try to understand what's going on. But it's maybe easier if Duet AI just gives you a full explanation of the SQL statement that was provided to you. Or who has had the situation where you wrote some SQL a couple of months ago or a year ago, and now you have to look at your own statement, and you kind of go, oh, I should have added more comments to this statement. Well, here Duet AI can help with that as well. I mean, that happens to me all the time. SQL generation. We're going to see this in action in a minute as well. You basically, in natural language, you explain to Duet AI what you want to do, and it will generate the SQL statement for you. Also, while you type, no surprise here, it understands what you're typing, it understands the context, the data sets that you have available, the tables that you have available, and it can do some autocomplete of your SQL statements as well. And just as a reminder, because you've seen in the news situations where information about the prompts that were ingested in the LLM or the results of the LLM were somehow exposed to other customers or to on the public internet. So the model that we have around our large language models, we can talk about it in more detail, but basically it consists of frozen foundation models, which you can see on the right there. And those are, they're fixed, right? We train those, we build those, and they're locked. There's no customer data that is getting in there. Your prompts are not getting in there. You can't change those models. Then on the middle, you can see Vertex AI with the adapter layers. Basically, that's where you do the fine-tuning, and that's where all the information gets pre-processed before it reaches the foundation model. And everything that comes back is stored in your own perimeter within Google Cloud. So there's no risk of leakage of any of your customer data onto a foundation model, and then, of course, by accident, also having it available to other customers. So BigQuery and Vertex AI, of course, both part of our data cloud, they're tightly integrated. So we already had for years BigQuery machine learning directly through the SQL interface. Vertex AI can now be used in multiple ways directly from within BigQuery as well. So you can have really complex models in Vertex AI, where you've developed through MLOps on Vertex AI. You've built these models, you maintain these models, but now you want to use these models. And now through simple SQL statements, you can call those machine learning endpoints that are available on Vertex AI directly from within BigQuery. You can even, for lower latency and performance improvements, and if the model does not exceed the memory limits that are always there, you can import the external models directly into BigQuery as well. So that holds true for TensorFlow models, but it also holds true for PyTorch and scikit-learn models that are in Onyx format. All right, how am I on time? Cool. So let's see a demo. But before I do that, to illustrate it, I want to answer the following question: as how well are Benelux developers able to answer questions about SQL, right? So you want to write some SQL statement, and you kind of go like, oh, I don't know quite how to do this. So where do developers typically go if they have questions? Stack Overflow. Now, Stack Overflow has an annual survey. Anyone answered the survey from Stack Overflow? All right. And the great thing is, Stack Overflow publishes the results as well. So what I've done, no, not thank you. What I've done, I've used Dataform. So let me quickly duplicate this and go to Dataform. That's Analytics Hub, Dataform. So Dataform is our pipeline tool, as I mentioned. So here I select basically my Git branch that I'm working on. So I've loaded the data, and in Dataform here, I'm telling this where the survey results are. And then I can basically use it to transform the data. Now, I've built a very simple transformation. As you can see, Dataform, of course, works based on SQL statements, but also on JavaScript. DBT works with Jinja templates, Python Jinja. Dataform works with JavaScript. So here I have a function where I transform the data. So the survey data came with a lot of NA values, which basically I want to be represented by nulls instead of NA. All the number values, those were strings as well, because the data is available in CSV files. I'm sure you all have been there. So you need to transform your CSV file into something more meaningful. So basically you can call those functions here. And I actually also create an additional column here based on the column above. So basically the language that people are using are a semicolon separated string. So basically I am looking for SQL, and I create a Boolean flag in the new table. All right, so having that, I have the table here. I can, of course, see the data. As with BigQuery, you can preview. Now you can see the null values. If I go to the end, you can basically see the responses. You can also see the lineage, as I talked about, directly in BigQuery. So this is the raw table where it came from, which I loaded. And then you can see the transformations that have taken place. Now, I ran the transformation a couple of times, so that's why you see 3 transformations. And if you click that, you can see the transformation in more detail here. So here basically you see all those functions being, how do you call it? Exploded into the individual case statements right here. And of course the result. The same goes for data profiling information. Again, this comes from Dataplex, but you can start a profile scan directly here. I can run it now, or I can see the historic results. Has something changed over time in the profile information, and you can see information like what percentage are unique values, what are the no value percentage, the distribution of the data, some statistics. If it's numbered data, right, you can see some statistics on what is the average, what's the minimum, and so forth. And last but not least, data quality is exposed here as well, where you can see I've created 3 simple rules. These are range checks. Data quality that we provide supports both row levels quality rules as well as table-based quality rules. So you can have, okay, this table should not have more than 1% of these values, something like that, right? That's all supported. So here there's one rule that is failing. I can look at it, and if you look at the data, it's the compensation that the people entered. So some people were entering that they were earning 12 million a year. So I put a range check on there. So either I should change jobs because some of the people, they were earning like a lot of money, and I went like, okay. But so as an example, I put a range check on here as well. All right, so let's go back to the question that I had and answer the question that we have. So how well are developers in the Benelux able to answer questions about SQL? So for that, I've opened here a notebook. So again, this is powered by Collab Enterprise, but I don't have to switch to something else. I'm here in BigQuery. Now, what you will notice here is that I'm using big frames. So I'm not using the regular Pandas data frames. I'm using big frames. So it's working directly on SQL. And I forgot to connect the runtime. So that's really unfortunate. So I'm gonna start it. And that takes a minute. So luckily I have a pre-run backup. So I'll talk through it and then I'll switch. So here I am setting up the session. I apologize. Here I tell the data frame where to find the data. And you will see the hyperlinks. So basically what's happening, everything you do with those data frames, they are translated in SQL statements under the hood. And you can inspect those by clicking on those job links, right? And say, hey, what are you doing? And so if you create a data frame and you do a filter, right, and you store that in a new variable, in a new data frame variable, then that basically becomes a temporary table in a hidden data set. Right, so it gets materialized all the time, and you work with that. And this allows you to work with crazy large sets with a familiar data frame interface. So let me see, is it already connected? Let me continue here. So what I'm doing is I'm inspecting the data. Stack Overflow provided 2 tables. One was the results, and one was what they call a schema. It basically explains what the questions of the survey are. And one of the questions of the survey is, am I able to quickly find answers to my questions based on the tools and resources that I have available? And that's exactly the question that I would like to use. So the next thing I'm going to set up a couple of filters because I'm only interested in developers in the Benelux. I'm also interested on the ones that are using SQL. So I'm going to use my newly created column that I created in Dataform. And then I'm going to basically check, so how many people actually answered in the Benelux, answered that question, right? So I'm looking for the not null values. And that's 340. So 2 of the 340 are you guys, if you answered that you work with SQL. And then what I'm going to do is I'm going to ask how many of those people do not agree with the fact that they are able to find answers quickly, right? So they don't feel particularly supported. And that's actually 146 of those. They don't feel like they are fully supported by the tools and the resources that they have available to find answers to their questions. So in other words, that's almost 43% of you. So now what if BigQuery or Google's Data Cloud can help with that? So how about Duet AI, where you don't have to ask questions, Duet AI can provide you questions. So here I have a table, just a sample customer table. I can quickly look at the data. And what you will notice is that for the email addresses from the UK, they are not formatted properly. So they should be co.uk, but instead they're co.uk. So that's incorrect. Now I want to fix that. But I'm not really great at writing SQL. True story. So let's ask our generative AI. So what I'm saying here, can everybody read this, by the way? Is this large enough? Okay. So create a copy table with all the records of my customer table. And the new table should fix the email addresses that end with co.uk by replacing the ending co.uk with co.uk. So basically that's what I want to do. And by simply pressing enter, Duet AI will give me the statement, and by pressing tab, I can include the statement. And you can see that indeed it correctly creates a new table, which they call customer fixed, because I said, please fix the table, so it makes customer fixed, and it gives me the SQL statement straight from there. Now, just as a proof point, let me see if this one is up and running. So it's connecting. Let me connect to a runtime real quick. It should have started, so I should be able to connect. Yeah, so I'm connected, and what I can do is I can run all just to, because it's a live demo, so I didn't want to, fake it. So here you can see that it is actually running directly within BigQuery, and it's going through all the steps. All right, any questions?
Don't be shy. Yes. I'll give you the microphone.
I forgot the name of the thing that the generative AI basically.
Duet, yes.
Duet, yeah. When it's doing something a bit more complex than what you said, when it needs to know where certain kinds of data exist in which table and so on, where you might have similarly named tables, would you then have to somewhere mention descriptions of tables and so on, or is it just working out of the box for something as complex as?
Yeah, so I think the best way to think about it is, what if you would ask your colleague that is seeing the same thing, and you are asking that person that question? Would he be able to figure this out, right? So if you have a lot of tables that have the same name, and you're not in your prompt giving that person the hints of what tables to use, then that person would not be able to do that. And it will probably start asking questions, what do you mean? And Duet AI will do similar things, right? So if it finds ambiguity in the prompt that you ask, it will ask for clarification questions as well. Yeah.
Okay, thank you.
Question there?
Well, I was wondering if the Duet AI also provides like suggestions all the way at the beginning. For instance, the data transformations, the data filtering, so that it gives you, like, you give it a prompt like, hey, I would like to do this with this data set, and then it could give suggestions because it knows the data set.
Yes, so this is where I'm not allowed to reveal what is coming. Duet AI, what you see here is, let's say, it's version 1, and we're super hard at work at empowering Duet AI to do a lot more in the data space. So I'm sorry I can't directly answer your question, but you can. I mean, it's a great idea. So maybe engineers at Google would have a similar idea. Could be, yeah.
When can we expect a new release?
Yeah, exactly.
Thanks for the presentation, Peter. I have two questions. At work, I use Databricks, and a lot of what I've seen today looks very cool, yet also very familiar. Duet AI, Databricks Assistant, seamless movement around Unity Catalog, etc. I was wondering if I had to choose between these technologies right now, why would I choose Google's offering? That's my first question, and I'll ask my second one afterwards, if that's okay.
Yeah, so Databricks is a very strong partner of ours, right? So Databricks also runs on Google Cloud. So where Databricks has a very strong foundation in Spark, right? So if that is the starting point of your data journey, you have heavily invested in Spark, then Databricks sounds like a logical choice to continue that journey. If that is not the case, if you have a wide variety of data sources that are coming in different formats, with the native support of Google Cloud, Google's Data Cloud, to support these different formats and these different databases, then Google Cloud natively, BigQuery as an engine, would probably make more sense, because there's a lot less transformation that you have to do, because BigQuery can handle those things natively out of the box. The other thing that I probably want to highlight is that, and that applies to some other strong warehouse vendors as well that you might be familiar with. What I try to convey here is that Google's Data Cloud is designed to support every user in the data lifecycle and every data use case. So it's not a best-of-breed solution for one type of workload. And that's a fundamental thing to ask yourself, or customers that I tell customers to ask themselves. Do you want, for one particular use case, a very strong solution on that particular thing? Or are you looking to simplify your application landscape, your data landscape, simplify the work, empower more users, support more workloads in the long run? And most often, the people that I talk to, they have a long-term vision of where they want to go with their data estate. And then Google Data Cloud is I think, a better offering, which is strong on the individual workloads by itself, but it provides a more broader long-term perspective for organizations growing and making, basically leverage the data that they have. I hope that answers your question.
Yeah, definitely. Thank you very much. Just one more short one. In the big frames, I think you called it in the API, you said that everything is translated actually to SQL and then executed. Is there a way to do that lazily as well, or is it always eagerly evaluated? Kind of like how you need to collect on Spark to finally get everything, and then it can optimize.
As far as I know, it's eager, so it will run automatically. If you want to do things probably more lazy, then probably Dataform might be a better solution to schedule these things later on. It can generate the SQL and then maybe use that SQL in Dataform for later processing, for instance. But you can, however, also schedule these notebooks. So, but if you experiment and you do your research, they will execute immediately. Yeah.
Thank you.
So, very last question.
Thanks, Peter, for the presentation. I wanted to ask a question, I think, which already touched upon a little bit, is for data types like images or satellite data or geodata, geometry data, is there any kind of support for like geopandas, like here is pandas? Because that's a problem normally in spatial data sets. And yeah, it's a brief question. And yeah.
Yeah, so this is like a super great follow-up on the previous question. And the answer is yes. So BigQuery has a very strong set of geospatial functions. It has a complete library to do all kinds of, like, give me all the places within this polygon. What is the distance between these on the Earth, right? All those things, there are native functions in BigQuery. You don't have to go to another application. The same goes for unstructured data, such as audio files coming from your call center or images from, still cameras, that sort of stuff. We've released what we call object tables. And object tables is a metadata representation of files that are in cloud storage. And then through, do I have 1 minute? All right, so I have an example here. So here I have a flowers table. And if I, let me query this real quick. It's super small, so I can never use Control Star, or Select Star, but it's so little I can do it here. So here you basically see all those files that are stored in cloud storage. And what I can do is I can directly, using BigQuery ML, so here there is an ML function called annotate image. So basically I'm here, and I can run this, I can tell the vision model, so Google has an out-of-the-box object detection vision model, right? So it understands images. I can run it on those object tables. So instead of having, to export that data and do it somewhere else in Vertex AI, I can immediately, and basically what I'm doing here is I'm looking for any flower image that is not a flower, and it actually finds a few that do not match basically the detection. And you can see the return from the Vision API. For those that ever played with the Vision API, right, you get a JSON, a JSON back with basically all the labels that it detects with the percentage on how certain it is that it actually detected that. So so you can work with unstructured. You can call like a native machine learning library, but you can also write your own code in, let's say, Cloud Run or in Cloud Functions, and then call those functions and do whatever you want to do. Have an event triggered to process it or whatever. So it's super flexible in that way. Is that an answer to your question?
Yeah, it's really nice.
Cool. Cool.
Thank you, Peter.
All right.
Thanks for your very clear story.
All right, thank you so much.
Of course, we also like to thank you.
Always good.
Always a good bottle of wine.
Sure.
Always the solution.
Great, thank you so much.
So thanks a lot. Great to see how Google is actually helping us and actually work more effectively across teams. So thanks a lot for sharing your thoughts. I can't wait to see that new release of Duo AI.
There are no releases. It's continuously
improving.
Yeah, exactly.
Can't wait. So please stay seated. Our next speaker about Funda GPT will join us in a few minutes. So please stay here, and I'll see you in 2 minutes.
Cool. Allow me to. Hoi zo.
So let's continue. Can I have everyone's attention, please? So we have our next speaker standing here, Sander, and I'm very glad to call Sander my colleague. Sander works as a machine learning engineer at Xebia Data, unfortunately in the Eindhoven office, which is far away from me. However, you might recognize Sander, because Sander is not just a machine learning engineer. Sander is also a DJ. So he was actually at ADE last weekend. So if you went there, you might have seen him.
Might have seen me on stage as well there. Yeah,
even on stage. So music producer, recorder, but also a machine learning engineer.
Yes.
So he's providing a lot of workshops, giving trainings, publishing white papers. And today he will talk about his side project,
yes.
I believe.
True.
Funda GPT.
Yep.
So if you ever want to buy a house, listen to this man.
I will show you
He's
how.
the solution.
Okay, so, all right. Thanks for the introduction. Very nice to be here. So, quick overview of today. I will talk about Funda GPT, a small little use case, what it is. But the talk is actually also aimed to get you all in the audience excited to build your own applications using LangChain and GCP and how to deploy it and the things that you need to think about. The challenges and how you can do it relatively easily at low cost using serverless architectures. So first we will give a use case overview, then we'll have a small introduction to LangChain. We will take a look at how we build the application. Some final remarks about building these applications some things that I encountered, and a Q&A afterwards. So yeah, Kiki already gave me an introduction. I am Sander, I'm a machine learning engineer at Xebia. I have a master in cognitive science and artificial intelligence. I'm a big AI enthusiast. I try to enable and help organizations to implement generative AI in their business by giving workshops, for example, and trainings. And I'm a co-organizer of the Eindhoven Data Community, which is a meetup group of around 700, 800 people in which we organize events like these on single nights. So if you are ever in the Eindhoven region, you know where to go. Maybe we have something nice that day. So a bit about the use case. I don't know, who is here from Eindhoven? Or Noord-Brabant? Oh, nice. Okay, there's one, too. Great. Okay. So Brainport Eindhoven is Europe's most innovative technology region. So companies like ASML, Philips, Signify attract top talent from all around the world, and this results in a strong demand for houses in Eindhoven. Eindhoven's number of inhabitants saw the highest increase of the 10 biggest municipalities in the Netherlands. So that's a lot. And for every 100 houses, there are 109 people looking. So what we see now is that there's a really strong demand, and this means that I have to respond quickly. My girlfriend is scraping her own Funda scraper because she's on Funda all day, each hour, like checking updates. And she has to be quick. But I didn't have the time for this as well. So I thought, okay, there must be a way to do this more efficiently. And I've heard a lot about LLMs. I gave some workshops with it, and I thought, okay, this is a really cool use case to see if we can use LLMs to automate this entire task. And that's what I did. So this is Funda GPT. It's my personal broker. I wanted to have an assistant that can do everything for me. I didn't want to schedule meetings myself. That should my assistant do for me. And also should send me notifications when something matches my interest. And I also should be able to answer any additional questions that I have. In like a very conversational style interaction. It shouldn't really feel like I'm talking to multiple systems, just one entry point, which is a chat channel, and that should be enough for me. So this is what Funda GPT does whenever it thinks that the house came online that matches my interest. It sends me a Telegram message, and it says, hey, Sander, just so you know, a new house came online. I think this matches your preferences. This is because why? So it generates an advice. It formats the house nicely, and it sends me to it. It also adds a number to such that I can call the broker immediately. And for each house that comes online of Funda, it actually analyzes it and determines whether it's match or not. And it does this based on multiple factors. And I see some of you maybe thinking already like, hey, but Funda, the application just has filters, right? So why don't you just use filters instead? But I think what is nicer and what I found is that Funda GPT actually also takes multiple factors into consideration. So it will say like, hey, okay, you said you wanted to have 3 rooms. This house has 2, but the garden is slightly bigger. So maybe it's still worth for you to consider it or go for it. And the other time it said, hey, it has 2 rooms, but it has an attic, so you can maybe transform that into a room as well. And I was like, oh, this is really cool. Like, the generative AI thingy really gives advice. It really helps me. And I found that really, really interesting. And then the whole application is not really, the communication should not be one direction. So it should be implemented as a chatbot. I should be able to ask it for additional information, and when the information is not present in the previous messages, it should actually query Funda. It should go to the website and determine, okay, where's the information that I can use to answer my question. Second of all, I also, like I said, I don't want to schedule a visit myself, because then it still takes a long time. I just want to send a message like, hey, schedule a visit for me, I like it, that's it. And yeah, that's what this bot also does. So it reasons about my input and it links it to a specific action. So here we got this nice little bot. And in the following talk, I will show you, we will take a bit of a deeper look how it's implemented. But before we start, we have to, please note, it has two components that make it up. There's this notification service, which is a batch job that runs each hour, parses all houses, generates an advice whether the house is a match. If so, it sends a notification. We have the second part, which is actually a chat agent, which is a chat agent that actually can use these messages, but also my messages, to answer any additional questions or perform specific actions on my behalf. The important thing is that this all goes, this whole communication, through one channel, and that is one Telegram chat. So we have one single channel that can be used to give really a conversational experience. So how does it look like from a very high level? Now, we have Funda.nl, this is like our data source. That's what we use to scrape the houses. We have an LLM, like a service like OpenAI or Palm on GCP, that we use to transform the inputs or my prompts into outputs that we can use. And we have a chat messaging service, which in this case will be Telegram, because Telegram is awesome to use for this kind of systems. It's really, really simple, and that's my main reason for picking it. So, cool. Before we start, who is already familiar with LangChain? Who did already play around with it a bit? Okay, cool. Quite a bit already, quite a bit of hands, so that's nice. LangChain is this framework which is built around LLMs. It doesn't really host LLMs itself. It's like the glue to build LLM-driven applications. It's pretty awesome, actually. Like, you can use it to build chatbots, do text summarization, build agents, and a lot more. Like, the more I go into it, the more functionalities I discover, and I was actually pretty amazed by the things that it can do. And partly why I think it's amazing is because of this modular approach that it takes. So you chain together, that's why it's called LangChain. You chain together multiple components to build LLM-powered applications. Like this modular approach, you can, for example, the very simple chain is that it first generates a prompt based on your input, and then actually sends that prompt to an LLM. 2 steps, very simple, but it's just to show you why it's a chain. Now, and if we then look at these core concepts, we have a few things which I think stand out and are useful to know. We have chains, which are then the sequential collections of components that are performed in a sequential manner. We have prompt templates. Prompt templates are just prompts which are dynamic, so they can be parameterized. This is useful. And then we have LLMs. LLMs are not the actual models. It is a wrapper around LLM APIs, like OpenAI or like Palm, which you can use to plug it in your LLM-driven applications. We have indices, and indices, I think you should see them as a way of structuring documents to embedding such that LLMs can best interact with them. Then we have tools. Tools, I think, are one of the most coolest things of LangChain. Tools are specific operations that an agent can perform to interact with its environment, investigate the output, and use that to create a final verdict, a final output. And then we have, at last, we have memory. Memory is what's used to make agents stateful, to make sure or agents, or just that your conversational history is used when it creates a new response. So building the notification service. Let's look at this pseudocode. What we do is we first scrape Funda to get all the URLs of all houses that came online in the last 24 hours for a specific region. For the last 24 hours, because that's the lowest you can go. I would rather do each hour, for example, but Funda doesn't allow me. Then we loop over these URLs, and in pseudocode, we actually do this. If that URL has not been seen so far, we get the HTML. We then use a first LLM to transform the HTML into a predefined schema. And then we use that schema, which is just the properties of that specific house. We use that to use it as a prompt template to create a prompt. And this prompt is like, hey, this house just came online. Do you think it's a match, given my preferences? And then I store the preferences as well. And if it's a match, then we just send the message. And we make sure that this LLM always responds nicely in a nice and formatted way, such that we can use its advice in downstream applications and embed it in the whole chain of operations and business processes that we need to build around it inside the whole system. And if that's done, we add the house to the database and we repeat this each hour. Really simple, actually. So how does this look like in code? Now, before we start, we do a few tasks. We load some configuration. We just have this configuration stored inside the repository in this case. We define an LLM object, and this LLM object is a wrapper around an actual LLM API. Then we define a scraper to parse the URLs. And for this, I just found a very nice package online, which was called Vanilla Scraper. It did exactly what I did, so I thought, yeah, why build it myself if something is already existing, right? So this I just used to parse all the URLs. I did some modifications to the source code, but it works quite nice. Cool. So let's look at the code. First, we check, is this house already parsed? Does it already exist in Datastore? For the record, Datastore is Google's NoSQL database, really useful to store these kinds of documents. Now, if it doesn't exist, we parse the HTML from the web page. A really, really simple operation. We just do a request.get, and we get the HTML. We transform it a bit using beautiful soup to remove all kinds of characters that we don't want. And then we do a bit of logging, and then we return that file. And then I think here we get the first interaction with LangChain, where I think the LangChain is really shining already. So we transform that raw HTML content, which is basically unstructured content, and we extract the data into a specific house schema object, and we will take a look at that. So let's look at this function, extract data. So for this function, I use this specific LangChain function called create extraction chain pydantic. So here we are seeing the first chain that we will use in the application. And what I'm actually doing is I'm defining a schema, and this schema is a list of attributes that I want of this house that I want to fetch. Things like the city, the street name, the house number, whatever. And I'm passing this to that specific function, and I'm passing my LLM, and then I do a method on it called .run, and I pass in the content. And what now LangChain for me will do, it will just parse this structured data based on the raw HTML that we just got. And now what we have is we have this really nice schema that just matches, that contains the properties. And I think this is really nice already, because here you can use LangChain to get structured data out of unstructured data with a lot of easiness, without encoding any heuristics, without encoding any prior knowledge. It's like, boom, extract this and this and this for me, and here it goes. I love that about it. And then we go to the second method. We have a schema extracted, and now I actually want to get an advice. So I have this other method which is written, it's called getAdvice. And basically what it is doing is it generates a prompt because I'm using a prompt template, and these prompt templates are dynamic. It's like a function that you can use to pass in that object that you just parsed. And I'm generating that prompt, passing it into the LLM, and then I'm actually getting an advice, which is like the structured JSON object. Well, let's take a deeper look in this function. So this function generates prompt using a predefined prompt template. And here you can see why it's a template, because some things of it are static and some parts of it are dynamic. And then I'm passing in, okay, I have a list of neighborhoods that I really like. So I say, hey, I want a house in these and these and these characteristics and these neighborhoods. And a new house came to sale with the following properties. And then I just inject that scheme. And then my last question is, should we consider to check this house? Now, then there's a last line, which is format instructions, which we also use pydantic. Which we use LangChain, because we actually say that it should structure its response based on a certain format. And we pass in again a pydantic schema. And actually what we can do with this is pydantic will automatically verify its response. And if that response does not adhere to that predefined schema, it will give a validation error. And this is really, really nice, because like these LLMs are quite creative, but they are very non-deterministic, and this makes them quite difficult to use in downstream applications. So these like data verification is really a response, like having your response in a structured format is really, really nice to use it and to really incorporate it in the application. All right. Let me check. Yeah, so to give you this is what that advice finally does look like. It has two actually keys, whether it's a match or not, which is simply a Boolean, and then motivation. Then we use some of the properties that we also pass in, that are properties from that house schema. And we use that to generate some extra attributes, like a Google Maps link. And we also inject that to the end result, because then we can use all these properties to get like a nice message for which we can send as a notification. Now, if the house is a match, send a notification afterwards, upload the entity to data store to make sure that it won't be checked again. Because we don't want to generate an advice for the same URL each time. Cool. And then, the last one is just send house. And I think this is why we use Telegram for these things. Look how easy it is to send this message using a Telegram bot. It's like 3 lines of code. You just pass in a chat ID and boom, there you get it. So it's really nice for applications like this, which you do like in your free time. You don't have to set up a lot of stuff. It just actually works pretty easy. Now, then we have this, and we have a collection of modules, and we have a main.py. Then we zip this function and its related modules, and we deploy it as a cloud function using Terraform, which is like infrastructure as code. Then I also, this is just a part of the script, I also deploy some things like a scheduler to actually make sure that the cloud function is triggered on like an hourly basis, but just an example. Cool. So we have a small part of it right now. We have this simple notification service that sends a notification each time a house matches, and it does this based on my personal preferences. So this is what the end result would look like. Cool. So we got this nice little service that notifies us when a house comes online that matches my preferences. It's already quite useful, but like I said, I wanted to integrate it with more features. Communication is way too, it's one directional at this point, and I don't really like that. So let's use agents. Let's create a chat agent. And I want this agent to be conversational, to have a conversational interaction about the previous messages that it sent, and it should know this. And it should be autonomous. And this, I think, is the most important. It should be able to reason about my input and perform specific actions on my behalf. So let's take a look at agents. Agents, in agents, like in a chain, a sequence of actions is hard-coded. Yeah? So it will just follow a selection of steps that you defined. With agents, actually, you use the LLM as a reasoning engine. So you provide it with a list of tools and an input, and then you say, hey, these are a list of tools. Given my input, what do you think is the best tool to use to generate a final answer? So it actually starts to determine which actions it should take and in which order. And this is really nice for this specific use case. So like, let's say how that would look like in this case is, I'm going to say to the LLM, can you schedule a visit? Then the LLM will retrieve the tools. Will say, hey, okay, I have 2 visits, 2 Python functions in this case. First one is called schedule visit, and I had this specific description. The second one is called get web page for more information. Now, then I said, okay, I think that scheduling a visit is the right one to pick. And then it actually runs the function on your machine that the agent is running, so it actually performs the action. Then this results in a specific output in the environment, which they call. And then they observe that result and it will, based on that result, so in this case, it just will output a status code as the return of the request. And then it will just say, okay, I think it was successful at this point, so I'm gonna just say that the visit has been scheduled, and that's its final output. So, how is this agent then defined? Well, I think also here LangChain is really shining because it's really simple again. An agent is defined with this initialize agent, by the way, is a LangChain code. It's not a custom code. You just say, I want to initialize this agent. I give an agent type. There are all kinds of agents, and the different types of agents are a bit out of scope of this talk. But in my case, I want to have a conversational agent. Then I pass it a list of tools. And as you can see, these tools, they are just Python objects that I created. I pass in an LLM, I add some additional metadata, and I provide it with some form of memory to make it stateful. And this is enough to create my agent. So let's take a deeper look inside tools. I have two tools declared. The first one is fetch information from Funda, and the second one is schedule Funda visit. And I think when you define these tools, it's really, really important to be very verbose in your description, because the description is what the LLM will actually use to determine what is the right action. And it will use that. Then you can also parse in this arc schema. And again, we use Pydantic as an example to give the LLM a bit of an idea of what that specific input is. And as you can see, both of these tools, they are actually a wrapper around this function that I created myself, which is called parse HTML or schedule visit. So this visit that I'm scheduling is actually just, I hacked around a bit and I saw what types of requests Funda was making to its internal API each time I submitted my form to schedule a visit. And I found out that you could actually simulate it with this piece of code pretty easily. You just had to parse the request verification token from its response and the cookies. And then we had it. So when I press enter now, it will actually it will actually make an appointment for any house that there is on Funda. So the LLM can use this nicely. And then, again, running the agent is simple. We just do agent.run, and we pass in the message from Telegram at this point. So there we get it. Now look at what this agent will do. So this queue, in this case, will be, data.text, in this case, is please schedule a meeting for this house. It will parse that text and will provide it as input. This will start a new chain, and based on the input that I give it, it determined that the action should be schedule a visit. And the action input is the URL that we had in this conversational history. Now, then it will actually, that action will return a specific output. And then it will have an observation, it will create one. And then it will say, okay, the visit has been scheduled. Please contact the broker for further details. Nice. There we already have our agent running that can do both answering additional questions and also do other kinds of things. So I deploy this agent as a cloud function to keep the cost low. And I can use the URL of a cloud function as a webhook for the Telegram bot. So this is really simple. You just create a request to this specific endpoint, and then you use it as webhook, which will mean that this cloud function will be triggered each time that a message is sent, and the message content is forwarded to that cloud function, and you can just parse it from the request metadata. And I can use that actually to run the agent. But then we have a final problem, because I'm talking about chatbots, and chatbots are stateful. They need to have some kind of state because they need to know what the user has said. Cloud functions, on the other hand, are stateless because they are executed each time with a blank slate, right? So they are just executed. They don't know what the previous cloud function has said. So how do we persist this conversational history in that case? Now, we can also use an external database for this, and in this way we can actually retrieve some kind of state. What we now are doing, each time that this cloud function is running, we retrieve the history from this data store database, which is just a NoSQL database. And if there's a history, so if this function does not result or result something, then we actually transform that message history to LangChain messages. And then we use that actually to declare the agent. And now this agent is declared with a set of previous messages, and it suddenly knows the previous interactions and all the things that it previously had said. And when the agent is finished running, we will update the database. So we finally send the textual output to the user using the Telegram API. So putting it all together, we have a bit more components now. We have a cloud function, one does the notification. We have another cloud function that actually handles all my incoming responses. And then I would say we are there, right? Nah, not really, because Telegram uses the cloud function as a webhook, and it triggers that cloud function each time the message is sent. But the problem is, let's say that that cloud function executes an agent chain. It can get risky, because that agent chain will take maybe a bit longer time. And if the response is not within a certain window, Telegram will say, hey, the message is failed, let's try it again, and again, and again, and again. And then you can get like this vicious cycle in which this agent will be bombarded and executed like a lot of times. And that's not what I want, because let's say that my action was schedule a visit, it will maybe schedule 200 visits for me, let's say. Yeah? So that's a problem if that can happen. We just don't want that. So what do? Well, we decouple it. We just split that cloud function into two separate components. The first cloud function forwards the message to a PubSub topic, and the second cloud function is subscribed to that topic. PubSub is like an event bus. I know you're familiar with it. It's like a Kafka event bus. Below you see a very simple schematic overview of how that works. But the point of it is that we now decouple the processing of these messages, and then we eliminate these unnecessary retries. So Telegram API will trigger a first cloud function that will publish a message on PubSub, and that all the subscribers to that cloud function will parse that message to that specific topic, will parse the message, run the agent, and send the output. So we decouple now the processing of these messages. So putting it really all together, this is what it will look like, and this is what I've been now deploying for, I think, a month, which has been really helpful in my own journey to get a house. So some final remarks. Using this serverless approach, we could keep the cost really low. So using cloud functions, especially when you use it for like a single use case, it's very, very cheap. It cost me, I think, around €1 or something, everything together. This is much cheaper than a personal broker, so that's nice. But when developing LLM applications, you have this external dependency, so you really need to be careful. Like, I had this one time that I actually end up, I don't know how exactly, but I almost ended up in a recursive loop in which like the LLM starts calling the function that actually starts calling the LLM. And that time, that's problematic, right? Because then you can go like easily make a lot of calls to that specific endpoint. The same was what I just described. If you don't decouple those messages, you can get into these similar situations. And that's because we have this external dependency that actually costs quite a bit of money to query. So you have to watch out for this when developing. And one nice thing to tackle this is by using these things like dummy LLMs. That's also something that LangChain offers. So it's actually behaving exactly like an LLM, but it just responds random outputs, which you can use nicely in some cases, also for the agent, for example. Then also, yeah, cloud functions, they are fine for now, but of course they really don't scale well for batch jobs. I really wouldn't recommend to do any batch job in the cloud function. You do have to use some other tricks. But in this case, it was fine. The reason why cloud functions don't scale well, by the way, because they have a response latency limit. So if the function takes too long to execute, it will just fail. And that is not what you want for batch jobs. And then LLMs, they are awesome, right? I'm a big LLM fan, but they really have a limited rational understanding. So to give you an example of this, I had like this one time which I said, okay, I want a house with an energy label D or lower, that's fine. And then it said, oh yeah, this house came online, it has an energy label A. It's not D, it's not lower than D, so yeah, unfortunately it's not a match. I was like, come on, like this is really simple stuff, and it didn't know it. I have to say that in this case I was using OpenAI, upgrading to GPT-4 solved the issue, it didn't have it anymore. So what I'm now doing is I'm using different LLM types. For more simpler tasks, I'm using cheap LLMs, and then for the more complicated tasks, like getting the advice, I'm using the more sophisticated, expensive LLMs. Also, be clever in how you structure the responses. Like you see, sometimes you can use these you can use all kinds of these tools to structure responses, and you can use this also as building blocks to generate new attributes like Google Maps links and everything, and it makes it even more fancy. So that's also nice. And then also the last thing, this is more related to PubSub. I think that PubSub has its own challenges again, so it solved one issue, but it actually gave me new issues. One of this is, for example, that PubSub does not always do exactly once delivery, especially in data engineering. You have some complicated things to actually make sure that you make sure that the messages that it's sending, that you process them in such a way that you're not getting the same message all the time again. But yeah, in my system, I was like, okay, this is enough. Let's just solve this another time. But also there, it gives its own challenges. And I think yeah, that was it. So I hope to get you a bit inspired with this talk on building fun stuff in your free time and how you can automate stuff using LangChain and GCP. So that was it.
Any questions for Sander?
Yes. Is the code available somewhere?
Not yet, but I can make it available if you, yeah.
At least the presentation, I'd like to...
Only for sale, right?
To collaborate.
I had the same question, but I have another one. You mentioned Scraper. That's already a kind of public library or something. So more people are doing this?
Yeah, that scraper was actually, it was just scraping funda. It was setting some attributes, and there was like pretty deterministic. But there's actually a big funda scraper community online. Maybe I can start another meetup group for it. Yeah, that's true. Yeah, so yeah, people are doing it.
Great presentation, thanks. I was wondering how many times have you had to reschedule the visit that was scheduled? Because you didn't say that it's integrated with your calendar yet.
Ah, that's a good one. So what it actually is doing is it just says, hey, can I schedule a visit? So then the broker will respond to me like, we'll check, oh, who's the quickest? Usually, and then they will say, oh, that guy, so hey, when are you available? Or, oh, we have a few appointments in the next week, you can go to this, and this time, let me know. So in this case, I could actually maybe expand it again to also respond to these messages. But then, like I already spent quite a bit of time now, and I think my girlfriend also wants our weekends back, right? So
first of all, thanks for the presentation. Really nice solution. I do have a question about like the parsing of the Pydantic base models. I'm not sure how it works like in the actual code of LangChain, but I tried to do it custom with just Palm actually, just asking. I think it probably asked like, hey, can you return a JSON response, and then probably Pydantic parse it. That's probably what's happening. Did you try Palm also? Because I've tried Palm before, and the whole JSON thing not always works perfectly. And I was wondering, do you know if GPT works better? Or
yeah, I'm actually trying to move to Palm. So because I'm now deploying everything in, I was working on this app, and then I was using OpenAI, but I really like GCP, so I thought, okay, let's just convert everything to GCP, and once we got this running, let's just switch the LLM part to Palm as well. But I haven't really had the time yet to do it, but I'm wondering about it. I do think that Palm is optimized on some aspects for code generation, right? So you can actually select the model, and maybe I can imagine that the Palm model optimized for code can be better than just the average Palm, or like the normal model for text.
I think that's the Cody one, or the Duo. I'm not sure, but I didn't go there. I'm just using the Palm as is, or fine-tuned.
Yeah, but it's an interesting one. And I'm actually wondering, I had this discussion with a few Xebia colleagues to also indeed understand which models, or just do a small research, which models are actually best in parsing outputs. Because at this point, I see that as one of the best use cases, or at least for me, as one of the most powerful use cases for LLMs that you already can like use quite easily, right? So it's an interesting point.
Let's keep in touch.
Yeah, nice.
Thank you for the presentation. I have a question. I think you only use the textual data for your agent. I was wondering, like, if you also considered like using the images that Funda also generates to. I mean, is there any tools?
I think that's really interesting, actually. So now you're saying it, I'm actually thinking out loud. So there are these multimodal models, which are now entering the stage more and more. So we can use both textual and image inputs. And actually, that would be really nice, because that's, I think, one of the limitations at this point is that it just does it on text. And one of the nice things now is that when I send a URL using Telegram, it will automatically inject one image. So I can immediately see like, okay, this is this type. And I can use that to quickly filter whether I think it's interesting or not. But it is not really like artificial intelligence here that does the insight. So I think using multimodal, we can go actually much step further. So that's actually a really interesting point. Yeah, maybe next year we have a follow-up about this multimodal agent. Yeah, nice.
Oh, thank you. Yeah.
Thank you. Yeah.
We have next guest speaker already for next year.
Yeah, exactly. Yeah.
So I have a suggestion that you could, because you parsed the Google Maps link, you could also use the Google Maps API to figure out how close is it from the central station, how much biking time it takes,
true.
And you could have a filter on top of that.
Yeah, that's true. So indeed, that would be cool because then you can also generate some new attributes based on the attributes and then use these new generated attributes again to send another response to the LLM. And then you can get like more and more interesting responses and tailor these suggestions more and more to your use case. But all these questions I really like because this was exactly what I wanted to do with this talk. So let everyone here start to think about their own use cases and how they can use LLMs as well. So that's really nice.
Do similarity search. If you like this house, you might like this house as
well. Yeah, also, yeah. I think I just have to take a holiday, a week off or something to implement all these ideas.
Speak to Rob.
Yeah, exactly. Yeah, and the meetup group, yes.
So time for one more question.
Or even process images. For example, in the image it shows that it has truss, but the user didn't add in the description that it has a truss. Taking to cut through.
Exactly. Yeah, that's like pretty inspiring to hear all these new things already. And I think like with this new multimodal models, that it really opens up some new range of possibilities.
The Funda innovation team should spend some money on it.
I actually sent it to Funda, but I haven't really. Yeah, we did get a response, but I cannot really go too much in depth now at this point.
Have you already found your dream house, though?
Yeah, so I actually found it, but I got overbidden. But it was nothing about the AI. It was just Eindhoven and its competitor. Like it can solve a lot of things, but like increasing my paycheck maybe still too difficult for it.
Is your boss around today? Or,
just kidding.
Well, with that, I would like to thank you for your amazing talk. So, a nice bottle of wine for you.
Thank you.
And a warm applause for Sander. Which also brings us to our very last talk by Wessel. So we'll need 2 more minutes to change, and then we'll kick off. Please stay in the room, though. Thank you. Okay, guys, it's time to kick off again. Sander.
Ze zijn ontzettend.
Okay, guys, so let's continue today with our very last speaker, Wessel Huizing from Miro. From Molly. From Molly. Has anyone ever successfully managed to bring an LLM to production?
Yes.
I think your story is will work out. Anyone working on LLMs? Not too many, okay.
Oh, okay.
Might not be successful.
I will see.
So today we have Wessel around. Wessel's actually a great cook, a coffee lover, lives in Amsterdam. So if you have any tips and tricks on coffee beans, he's your man. But he also knows a lot about how to bring LLMs to production. So give him a warm welcome, Wessel.
So, hello everyone. You can hear me well? Yeah, I can hear myself. So, actually, I was not the last talk of the day. Sander was actually the last talk, but he got placed in front of my talk. So I'm not sure if that plays out very well in my case, because it was a really nice presentation. But I will try to beat it today. So today I will talk about from MLOps, machine learning operations, to LLM ops. And we'll try to successfully navigate the generative AI boom. And generative AI boom, I think we all know the moment that ChatGPT came into our lives. And a lot of things happened, right? So today I will try to give a bit of pointers. How can you start with LLMs? What if you have already, what is a machine learning platform? What if you have already one? What do you need to add to your machine learning platform to get yours kicking off? So a little bit about me. Actually, I've been working at Molly for almost 2 years as a machine learning engineer. I'm living in Amsterdam for a pretty long time. I did my bachelor's here, my master's, and I think I'm already living 13 years here. So I'm morphing into like this old Amsterdam guy in the bar. Xebia, I actually met Xebia also 2 years ago when I started Molly, and it at the time was called GoDataDriven, and I worked together with a lot of really good people on creating this machine learning platform, which I also will explain a bit later. So I do have a question also for the audience. Who attended the Google Cloud Summit 2 weeks ago, 2-3 weeks ago? Okay. So actually, there are some slides from this presentation, but I try to add my own flavor onto, so we will go more into depth, I promise. So it might look familiar, but actually Ryan, that's my manager, and Diederik, also from Xebia, gave this presentation here. So there are some credits to them as well, but I mean, I'm actually working on the use case, so I will have more technical use cases. So. Now that's almost there. So first of all, we're going to talk about Gen AI. What's this Gen AI thing? Then we will have a look what's modern MLOps. Then how can we adapt these machine learning platforms to LLM capabilities? And then we have some outlook. So to start, like I mentioned, we all know this moment, some time ago, and people found out about ChatGPT. And then everything exploded, right? You couldn't go to your barber and he will be talking about like, hey, I asked my ChatGPT how I should cut your hair, whatever. Everybody will become an expert at some point, right? But there has been happening a lot before ChatGPT. Actually, on the right side, you can see that they've been busy on this whole generative thing since 2014. Actually, the first GPT was released in 2018, and that's pretty a while ago, right? And then BERT came, and everybody forgot about BERT, and now it's only GPT, and now a little bit of Palm as well. But there's also a good thing about this boom. I mean, it's here to stay. There are some new cool use cases which we can definitely reopen, like the whole chatbot thing. Do you remember like the whole chatbot? There's like just a tree, right? It was like yes or no, and then maybe there's a new answer. It's not really conversational. But now we can do pretty much more with it. Also, generation of text. This all opened up this new way of looking at machine learning. actually, I also created a horoscope generator, a Dutch one, in 2021 with GPT-2, but nobody cared at the time. So that gives like what happened. Actually, no, but I did it. But it's some while ago. So we're already doing this for a longer time. So this is like since then, I mean, exploded. These are all like companies who jumped on the hype train. So I know like if you want to start here, this is a bit overwhelming, right? So like where are you gonna go? So hopefully this presentation will give some sense to just start. Actually, that will be the takeaway. So what's MLOps? So MLOps, we just go over it. MLOps is creating like reliable, tested, and reproducible modular machine learning solutions. So with the reason to have lower operational cost, also improve the life of data scientists and machine learning engineers, and maybe also some analysts, you never know. And you just want to go faster to market, obviously. So how does it look? So this is obviously a small image, but it gets the most important part. So every time you start a machine learning project, you first need to think about design, the ideation, some use cases, what's the value, maybe some prioritization, right? So you need to have buy-in from your stakeholders. And then actually the phase of experimentation development starts. And this one, it's familiar. Also, without a machine learning platform, you know this phase. You need to find the data set, you need to do some analysis, some EDA, then you have a train and a test set, and everything what you normally would do to create like a good machine learning model. But mainly the focus and the value of like getting fast to market is in the operation level. And nowadays it's called the CI/CD, and even they added CM, which is continuous monitoring. But this operation part is all about versioning, code versioning, but also model versioning, lineage tracking, like what data set actually trained this model at the time we trained it. Although we already have 5 new model version, but you still want to go back, maybe some validation, monitoring. So everything is more around this operation part. And that's actually where MLOps thrives. So to get to a good machine learning platform, I would say you have some infrastructure layers. So if you want to have like a good machine learning platform, you definitely need a good data foundation. And this data foundation will obviously have all the data in there, but it's good to have the right access tools. Also, the speed of creating new data sets, having the right access, permissions, anything what you would need. And for a good data foundation, you need a good cloud foundation, because just what I mentioned, you want to easily just create data sets. You want to maintain and make sure that it's hosted well, that there is availability. All these things are on top of each other. So actually, I stole this image when I was at the Google Cloud Summit as well. I found this like a really good image, like what are the requirements for a machine learning platform. And in here you see in the top, there's this focus on developing, iterating, also some experimentation. But at some point you will get into the code, into building blocks. You want to create a pipeline, but you also want to iterate, create components, and then you want to make sure there's a source code repository. And from there, you want to focus on automating this pipeline. So whenever you are done with the development, make sure you can automate it. And you want to do some lineage tracking. The model, you want to save the model, but also deploy it in an endpoint. And from here, you want to monitor the usage. You want maybe to batch predict, maybe some real-time prediction. And there should be some triggers whenever there's data drift. So everything catches in this image. But it's a bitty, I can see it's a bit, there's a lot going on. So we can also say, what are the main functionalities in a machine learning platform? So I'll just focus on what we have in Molly at this point. So we have actually workbenches, which are Jupyter Lab environments, where you can do experimentation. And we have actually also Spark, so you can also have some interactive Spark. Spark is used to do like a lot of heavy data processing, but you can also do this from this developer environment. From there, we have some training pipelines. We are using Vertex AI pipelines built on Kubeflow actually. It's a managed solution. And for model management, we also use Vertex AI models, but also using Google Artifact Registry to save Python packages to save Docker images with the right versions and tags. And last but not least, we have inference and prediction. So in here we also use Vertex AI endpoints actually, and Cloud Run, I think it is. But to actually tie all these things together, I have a nice overview. So in here we have, at Molly, we have a data scientist or machine learning engineer or even an analyst. They have a laptop, obviously, and they are using an IDE. We most of the time use VS Code, and we use this to SSH into our cloud platform. And everything in our machine learning platform is hosted in GCP, actually. So then you would SSH in this virtual machine, which is called the Vertex AI Workbench, where you have like a developer environment. You can use the Jupyter Lab UI, but you can also just use it as a virtual machine because you have the right permissions to the data sets, but you don't have to work in this notebook fashion. From here, we can also Spark, because we have the right permissions, one of the Vertex AI pipelines, which is a managed Kubeflow instance. So we can create pipelines, we can create components, so we have some DAC going on. And both are using or consuming data from a data warehouse, which is maintained by our data engineering team. So we have the right permissions, we can do with the data whatever we want. We have also Mart, which is like clean data. Everything is working with version control. We're also using GitLab CI to deploy the right Docker images, to kick off even Vertex AI pipelines, but also we're using GitLab Schedule to even schedule pipelines every week or every month, whatever we need. Then we have the other things I was mentioning. We have endpoints. So from the managed Kubeflow pipelines, we will create endpoints, but we also will upload models to the model registry, and also will push these models, if necessary, if we want to the endpoints. We have artifact registry, where we also save other Python packages and Docker images, which are needed to run these endpoints, these custom containers. And most of the Molly apps will consume, in the end, the endpoints. So any team wants to use one of our machine learning models, they probably will just send GET requests in the end to our endpoint, which is a REST API. All of this is hosted within GCP, but also provisioned using the Terraform, which is a tool to apply infrastructure as code. So this is actually how we are applying it in Molly. There are some extra things like experiment tracking, some monitoring, but that's not on the slide. But I think this grasp it's well enough. So now we're finally at the point. What then is LLM ops? It sounds like something I made up. I did not, but maybe someone else did, because I think it's not even a thing. But it's a buzzword. So in the end, but it's a good, maybe helpful, because it will add some more focus on the whole MLOps part. As you can see, it's a tiny bit of MLOps, but as you can see the Google Trends, it's happening. People are searching for it, but actually just you want to adapt the current machine learning platform to use also LLMs. So if you have like a good foundation, it's pretty easy to also get started with LLMs for in production. I want to then dive into actually for companies like Molly, and I think most of the companies, there are actually two use cases. We have a lot of things going on around text generation, but if we want to be fair, I don't see how Molly is gonna write a book for every merchant it has. We probably won't need it. So we have two things which are mainly the focus when you want to use the LLM. And one is classifications, and the other is just a question answering, which more like chatbots, right? I will dive into how to use these LLMs in these use cases later on. So if you want to look at what are the requirements for LLM ops, if you want to enable it in your machine learning platform, there are three things actually. So the first one is the zero-shot approach, which is just use an LLM as it is. So like it's how it's running. So that would be like just changing the prompt, just use GPT or Palm, or however you want to use it, by just changing the prompt a bit. You can test it out. You make sure you have a test set so you know the changes of the prompt are actually improving or decreasing performance. The second one is a retriever. So that's also a thing. Nowadays, a lot of people are talking about a vector store, which is also really relevant if you want to use question answering or for like internal documents or even your help desk page. The last one, which you definitely need, is fine-tuning, and that's retraining the last layer of one of the LLMs that's enabled to fit your use case. This is most of the time used for classification use cases, but I will dive later into how to actually use these requirements in an actual use case. So I divided the machine learning framework requirements in 5 layers, and I will start at the lowest part. So like, what would you need to actually go from just using normal machine learning to actually applying LLMOps? So the cloud foundation, the left side, that's actually what you should have in place, and the right side is what you might need. And this one is quite straightforward, it's pretty easy. You just need to enable an LLM. And we are using Google, so we just enabled Palm, actually, for our use cases, but you could also use OpenAI. There are some caveats there. So for instance, why we use Palm, and that's because we're using GCP, but there are also some reasons behind it, is actually for privacy reasons. So the Palm API can be enabled per project, and the fine-tuning aspects, the models only save the weights, and they save the weights in your project. So that's the last layer. So if you fine-tune and use some documents which you don't want to send over the internet or just don't want to leave the project, that's no problem, because you will retrain the model only in the project itself and only will save the weights as its last layer. So you have performance. Actually, what also is nice about using these enabled APIs like GPT, but also like Palm, is that there's a whole team working on improving this thing constantly, retraining. That's all things you're not able to do yourself. Let's say you want to host Llama 17 billion parameters. It's pretty fixed, right? It won't improve over time. That's just what you get. Also think about costs. You want to maybe do back of the envelope. If you want to host your own model like Llama, which is fine, of course, you need four GPUs. That's actually what Google tells you to do. So before you want to host your own models, please think about cost, because Palm is pay per character. While Llama, of course, you can host it and can use it as much you want, but you also need to host it and you need GPUs. And those are pretty expensive in the end. So if you want to start quickly, please just use enabled LLMs like Palm or GPT, because it all will, it's a good way to start and not explode your cost in this sense. The second layer is the data foundation. So if you want to work with LLMOps, you might need some new data sources. Some of them you won't think are traditional. So like conversation history maybe with clients from email, could be anything. But also internal documentation. Sometimes they are not even saved, but they are hosted with a third-party service. You need to get those in. The next one is the MLOps platform. You definitely will need to add a vector store. And a vector store is something which is able to save embeddings. And embeddings are used mainly by use case like question answering using a vector store. And I will quickly go over it. An embedding is something that can transform a lot of text into numbers, actually, and it will grasp the content. So what's happening in this document, and it will transform it to a vector. And a vector are multiple numbers, but the nice thing, you can actually compare those vectors to see like how much overlap are there between the documents itself. So for question answering, that's pretty helpful. So let's say you want to do question answering on your internal documents. So what you would need is an embedding model, which is also provided by Vertex AI. And you should transform all documents, all internal documents, into these embeddings. And you would store these in a vector store, actually. You can add some metadata, which is the original document, but also some any metadata you can add to it. So that's why you have the vector store in place. And whenever you have a question about, and you want to ask like over your internal documentation, a question like, I don't know, like what's the best way to SSA into my workbench? We have some Confluence documentation. You would embed the question using the same embeddings model, but then you will query the vector store, which has all the embeddings of all the documents, and do a similarity search. And the similarity search, for instance, will respond with the top 3 similar documents. And you would use it inside the prompt, inside the content. So that's where you want to go. So as you can see in the below, you have the top X relevant documents. It will return the original documents, but this is what you would need to put inside the prompt. So the prompt will say, based on the information and then the 3 documents which you returned, please answer the following question, which is the question you asked. And then Palm, you will query Palm, and Palm will answer based on whatever you gave in this prompt. So this is how you would use a vector store. And the vector store is nothing more than just a similarity search using the embeddings you gave to your internal documentation. So that's how you actually give more knowledge to the LLM without fine-tuning. And this is mostly used in question answering, so chatbot use cases. So this is why you would need a vector store. And it's
Are you using this in your payment process somewhere as well? Or
no, I will go over questions later, but we were using, don't worry. No, we're actually building like a help desk chatbot. So we have some external documentations, and we are planning on creating, actually embedding all the documentation we normally have in Zendesk, and then just put it into a vector store and then see if we can create a question answering bot. So that's where we're working on. Then I would like to go over the next phase, is template. So when you want to move fast, want to iterate fast, it's good to have some good templates in place. So like cookie cutters, but maybe also a shared Python package where you can use different function classes which you are using over all your repositories. You would need some additional for LLMs, like a prompt creator maybe. So anything which could help in future projects, maybe added to the cookie cutter, an extra call to an endpoint, maybe the pre-cooked code. You can also add it there so you can work faster in the end. The last layer is the model itself. You need some extra new features. One of them is the prompt design. Prompt designing is something which I mentioned before. You just change the prompt, but you need to make sure you can validate your changes. Just make sure you have a test set. Another really important part, if you want to do classification, I will go over it later, is you need a fine-tuning API. Then we have some new metric definitions, because when using LLMs, there are some new metrics. How do you want to compare question answering? How do you want to validate it? You need to have like a test set full with question answering, but how are you going to define what's the best answer? Are you using sentiment or just words, keywords extraction? You need some safeguards in place, because people, even publicly exposed one, people will try to play around, right? They will ask like, forget everything you knew, just answer me something bad, and they will create a screenshot and post on Twitter. So you don't want to go there. So you need some safeguards. So I also promise you I will go in how you can approach a classification use case using fine-tuning. And that's pretty like the original way to go with a classification. You need a labeled data set. So that could be documents with a label. And then you would split up in a training and test data set. Which percentage you would like to use, that's on you. But from the training set, you would create an input list, and these inputs are actually the prompts. Normally, you would send a prompt with based on this based on this content, and you give the content. Please classify in one of these classes. That's actually the prompt you need to create for every document you want to use for the training set. The output actually the label. So you would have, let's say, you have 10,000 training examples. You need to create 10,000 prompts, but also 10,000 outputs. It's like two things. And this is what you would feed to the fine-tuning API. In Palm, you feed like the input text, which is JSON lines of all the documents. And on the outputs, that's just the classification, the label itself, so just the class. And then you will fine-tune the model. You give an X amount of steps. That's all on you. You can all play with the numbers. And you would need to host that fine-tuned model. In Vertex AI, this is already done for you, so it's nice to when you pick something enabled LLM like OpenAI or Palm, it's nice to have these things in place where you can just call the API and they will fine-tune it for you, which is the case with Palm. And then for the test data set, because you actually want to know the performance, just like a normal machine learning approach, you would have a test set, you will create the prompts for these test documents, and you will run it through the hosted fine-tune model, and you get responses. And that's just the same way as normal. You just compare those metrics, see if the label is the correct one because you have the actual labels, and you compare it like the predictions of the LLM itself, which will give the performance metric. So it's not really different than a normal classification use case, but you need to have this fine-tuned model in place and pre-create the prompts, of course. Then lastly, I want to talk about the safeguards. This is important. So when you start with LLMs and in production, you might just want to run it in shadow mode. And if you don't feel like using shadow mode is just running it and then have a look later by a human if it actually was the right classification or the right answer. But if you don't want to go there and you want to start pretty fast, you also, I think in the beginning you want some human in the loop, right? So if you want to test it, see if it works out. How are the users even publicly exposed solutions? Maybe try to see if the answers are correct if you use a help desk use case. Also, which is nice is that if you have a human in the loop, you can also label these answers. Let's say the model gives an answer, and a human can also say the answer is great or the answer is not great. In that case, you can use this data, which you want to save for later, to fine-tune the model again. So you know what's the correct answers and what are the wrong answers based on the question. So also these things you want to save, but also you want to label those by a human in the end. Good to also keep into account are the data silos. So sometimes you also want to make sure that the data that's exposed to the model is siloed. So if you have a vector database, you don't want to, and that's used by the model, don't upload documents that should not be exposed to your customers, because it will use it. Or some information about your merchant, please don't use it. Make sure the data is also siloed. So if you have different use cases, make use of different vector stores for that case. And last but not least, like people will try to ask funny things to your model. Get some filtering in place. It can even be some keywords. The good thing of using a hosted LLM like Palm is that they have these things already in place. But still, you need to check like what's the output, especially if it's publicly exposed in here. So let's go over the outlook. So it's boom without a buzz. Yeah. So it's worth the hype. So we have the non-code solutions. We know about 3D printers. We have seen a lot of hypes, but none of them got so much traction as we do now with the LLMs. And I mean, it's worth it. We have seen it. There are some nice cool solutions. You can actually ask Funda now as your broker, as you've seen the presentation before. So it's really worth the hype. And the good thing as well that there's more increase in attention to machine learning in general. So not even only LLMs, but also people want to use more machine learning in general for their use cases. Sometimes LLM is not the way to go, but you have definitely a lot of possibilities using machine learning to get to a nice solution. Last thing I want to say, keep in mind, there is some EU Act coming up, and that will regulate some of the things we want to do. So start today with looking to what's going to happen with the EU AI Act, because at some point they will implement it. So you better start today, keeping touch with whatever they want to have as requirements, because if the regulation will come, and it's a good thing, of course. So I have this closing slide. It's GenAI is here. Our machine learning operations practices must adapt to meet demands of business and bring a GenAI solution to our customers in a scalable and responsible manner. It's really, so this is the takeaway, but also, I think, please don't be this guy on LinkedIn. And that's where I want to close the presentation. Thanks for all joining and listening.
Are there any questions for Wessel? Yes.
At Mali, like the LLMs for customer service, that's usually the use case at this point. Do you have any other use cases at Mali at the moment that you're developing?
I can go over into the details, of course, but yeah. So the normal help desk one is a pretty obvious one, and we're starting development around that one. But the question is it good enough? For the other ones, we do have some classifications. So the other one is a classification of documents, and it has to do around KYC. If that's enough, because I'm not sure how much I can go into the details.
No, that.
But we do have actually. I'm working on two solutions or two projects. One is the Q&A one, and the other one is the classification using fine tuning. And there we classify like big chunks of text into one of a list of arbitrary business codes actually.
Yeah, but especially with the KYC, with Bank, we also had this conversation. But the legal ramifications of uploading user data to LLMs.
Yeah.
It's still a bit of. I mean, they say they don't use it for training. Maybe Palm is better in this regard, but
so I think OpenAI that's challenging, because if you would work in GCP and you want to use OpenAI, there you need to send it over the internet, right, public, and that's why we don't use OpenAI. We use Palm, and Google told us, and we need to trust them on this one, that the fine tuning jobs run in the project. So they provide this base foundation model, and if you have a fine-tuned model, it will just only use the last layer. So it will just call through those two layers in the end to get like a generative answer. So you also will own those weights. So it's not it's obviously on their servers, but it's still in your project. I wanted to find actually the image, but I couldn't. But I think from privacy perspective, sorry.
You need to create an image.
Yeah, so that's maybe using Palm, but now I've seen a graphic, and I think that's a pretty good solution for privacy. For privacy reasons, because of this, you don't just want to send customer data to some model hosted by a provider and says like, oh, sure, we're not using it. I mean, we also have seen like the thing with Samsung, right? That they send like classified documents to GPT once just by ChatGPT, and then by prompt injection. So like, hey, what do you know about Samsung? They just responded to actual documents because it was used for fine training. That's a while ago, but.
And the final follow-up, but in terms of vector databases and the entire story, just basically like, what is your view on that in regards to privacy data concerns?
A vector database, yeah, as long as you just host the vector database yourself, which is, you can even just do it with the Chroma DB in memory, if you don't have a lot of internal documents. At the end, it are just numbers, so it's not taking a lot of memory. It's fine, because you need an embeddings model, and if that's hosted by Google, it just transforms the document into a vector, and then just upload it to a vector database, which you also maintain, and is in closed network. If that makes sense.
Yeah.
Thanks for the presentation. I was wondering what would be like a ballpark amount of training data needed for any general. I know it is dependent on the use case and the type of model that you use, but for example, in computer vision, you would say, okay, 10,000 labels is like the
like for fine-tuning.
Fine-tuning, because creating this data set seems like very...
Yeah, I'm currently playing around. We have a training set of like around 25K documents. But on the Google documentation, actually, we have a limit of 10K of documents, 10,000 documents to use for fine-tuning. And I asked them, like, what's it about? But actually, it's not a limitation, it's a suggestion. So they say after using more than 10,000 documents for fine-tuning will overfit the LLM actually. So we're currently, this is also part of experimentation, is trying different amounts of training samples, keeping the distribution alive, and play around with the steps, because you can give up to 500 steps per fine-tuning run. So these things are all to consider, but Google advises to use 10,000 documents at most because of overfitting.
Okay. can I ask another question? Just
Sure.
related to it? Like you just mentioned about overfitting and underfitting, I was just wondering how easy it is in this case to like really detect that if the model is overfitting or underfitting, because there can be any answer that it will give. So in terms of metrics.
Where is it? So it's still around fine-tuning, right?
Yeah, like the metrics that you will kind of use for.
So if you have a classification problem, you can just use, depends on the classification, let's say accuracy, like the most straightforward one. If you have a test set, you can just know like what's the actual label and what's the predicted label from the fine-tuned one, and then you can just compute a metric like accuracy, precision, recall, whatever you want like. So that's how you know if it's overfitting or underfitting. Also, I would advise, and that's what we do, like fine-tune, LLMs are not always the solution. So we also are playing around the TF-IDF, the most common document classification tool. And the performance is not even that far away from a fine-tuned LLM. So also create, in this case, it's a good question, because I would say create a baseline metric with a approach like TF-IDF, which is cheap because you just run it in your memory and then you're done. And then compare it as well to whatever you're going to do with fine-tuning. How maybe you can fine-tune with 200 steps, 300 steps, and then just get the one metric you want and just compare them, between each other, and then you know what is the best performance. The most important thing is the test set. Make sure it also has the right distribution, which mimics the actual base.
Thanks.
Hi, so thanks. I learned a lot from your presentation, so we really enjoyed it. And you also already answered one of my questions, which was about the performance of this model as a classifier. But another question that I had was about, like you basically mentioned, there were two use cases.
Yeah.
One is the chatbot, the other one is as a classifier. And I was wondering if you were saying that from the perspective of Molly, as of in general.
Yeah. So there was, if it wasn't clear, sorry. It's from the perspective of a Molly, and I would say as long your company is not a core AI product. I mean, the LMs are actually made for text generation and summarization. That's the best thing they can do. But in Molly, we don't have really valuable use cases for generating text. Or we have copywriters, and there is nothing really to win. So if you look at most traditional companies, Molly is a fintech, but it's still a bit traditional. I would say the most valuable use case where you can maybe use an LLM are classification and question answering.
Yeah.
Dot.
Thanks. Here.
Yeah, so I was wondering from a practical perspective, you were saying that for the question answering, you'll retrieve like the top end documents that are relevant and also add it to the prompts.
Yeah.
But you also said that you pay per character.
Yeah.
How do you manage this?
That's more expensive, depending on the size of the documents. But to be honest, the Palm is not that expensive. I think it's 0.6 cents per 1,000 characters. So it's you need to do the cost calculation, because like I mentioned,
I'm just thinking if you have one massive document that keeps coming
but
up.
you have also a window max token length, right? So for Palm currently it's 8K. It will open up to 32K. So then it's going to be expensive, but that's just how that's what you should consider. So if you say I want top 3 documents, what's the average length of a document or a paragraph, or whatever, how you split those documents, then you can do a calculation on how much calls a day, and please do so, because at some point hosting a Llama, for instance, will be cheaper than using an enabled API like Palm. But it will take long before it becomes cheaper. That's definitely true.
There's room for one more question.
I was wondering what considerations you took into account when choosing the vector store. Because I think there's a vector database boom as well going on.
Definitely.
So what did you take into account when making your decision?
Cheap, easy to start. So actually, there was not a lot of going on in my head. We talked about 5 months ago, and there was LangChain was also really popular at the time. It was like even I think Haystack was not even mentioned at the time, and they just used ChromaDB. And admittedly, ChromaDB is nice because you can just spin it up easily, and it persists on disk, so it also just loads up in memory. So you can also, for instance, if you have an endpoint, and in the end, like you need to put it inside in the endpoint. Like if you want to do question answering, the question will be sent to an endpoint, and the endpoint will need to call the vector store. But also, because ChromaDB is pretty light and persistent, you can also put it in memory of the container. It's not the best, but it works. And I think the takeaway is with LLMs, just start, and whenever the solution grows and grows, in the end you want to have a dedicated vector database, of course. But you don't need one. And I didn't really consider like a lot of options. I thought like ChromaDB database did the job. So maybe not the best, most fulfilling answer, but that's what happened.
It's a truthful one, so I appreciate it. Thanks.
Only the truth.
So that brings this talk to an end. So that also means that we would like to thank you a lot for sharing your considerations and being so open.
Thank you.
So thanks a lot. A warm applause.
Thank you.
It also brings day 2 of GoDataFest to an end. So there are 2 more days coming. Does that sound weird?
Maybe it's because the mic. Yeah.
Don't stand too closely.
I'll just walk away. It's better?
So I think we had a nice program today with 2 workshops. What is it? Machine learning. I wrote it down. The agenda was too long for me. Machine learning with graph networks. Machine learning system design workshops. So if you have still any questions left, please ask them during the drinks. And we had 3 great talks. One by Google, the keynote speaker, Peter, on the Google Cloud capabilities and how they can help you in your organization. We had an interesting talk of Sander, still sitting in the back, about Funda.GPT, his hobby project. If you're considering buying a house, please reach out to him. You're staying with drinks, right? During the drinks? So he's happy to answer any questions. He might start selling his product, so be careful. Be there fast. And last but not least, of course, the talk of Molly of Vessel, really sharing his thoughts on LLMs and bringing it to production. So thanks a lot for attending. I believe there are still tickets left for tomorrow and the day after for the online version. If you haven't bought any tickets, you can always join. And for now, I'd like to see you at the bar for the drinks. Thanks a lot.